Hello, 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 hello. Am I audible? Am I audible, guys? Hello, 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 hello. Meenakshi. Yes. Tinnale Chappu. Guys, what is this here? Hello, hello, Navya. Hello, guys. So, சொல்லுங்க உங்களோட preparations எல்லாம் எப்படி போகுது? சூப்பரா போகுதா? So, guys, am I audible? Yes. Good afternoon, Hari. Yes. Tinnavu. Tinnavu, guys. Tinnava. Tinnavu. Yes, I think, yes, I can see me. So, guys, so everyone quickly smash the like button. So, I think you all are, yes, ma'am, CBSE. Wow, that's really nice, Dada. Are you sure? Are you sure? Vanakkam, ma'am. Yes, vanakkam, vanakkam. Yes, did you had your lunch? Yes, I had my lunch, Dada. Yes, good. What is this, Hari? So, guys, உங்களுக்கு தெரியும். So, we already launched a free NEET crash course, okay? So, free உங்களுக்கு crash course கிடைக்கும். So, here I will show you. Just a second, guys. Yeah. Yeah. So guys, most of the students, almost 2000, more than 2000 students are using this, okay? So in the free NEET crash course use பண்றாங்க. So நீங்க இது வரைக்கும் யூஸ் பண்ணலனா அது ஒரு big mistake தான், okay? So because அவ்ளோ question இருக்கு and அவ்ளோ 100+ books உங்களுக்கு access பண்ணலாம் எங்களோட லைப்ரரியில இருந்து. So because இந்த டைம்ல like reference book எல்லாம் கிடைக்கிறதுக்கு நீட்டுக்கு அப்புறம் எல்லாமே தூக்கி போட்டுட்டோம்ல இல்ல. So yes, இதுக்கு அப்புறம் நமக்கு ரெஃபரன்ஸ் புக் எல்லாம் கிடைக்கிறதுக்கு ரொம்ப கஷ்டம் தான். So அதனால so here you will get 100+ free books, okay? So உங்களுக்கு 100+ free books access பண்ணலாம். So அதுக்காக இப்போவே ஜாயின் பண்ணிக்கோங்க. And அது மட்டும் இல்ல, here we are providing 45 full length mock test, okay? 45 full length mock test இருக்கு. So here you can see description box la. So description box la ungalku paatha theriyum. So in the session oda description box la first link join the free NEET crash course da irukku. So adu click panna, so you can see this buy now option. So ma'am, buy now option of free nu solite actually it is actually 0 rupees. Yes, so NEET, yeah, NEET crash course இருக்கு. So இந்த tab yes, இந்த மாதிரி ஒரு tab open ஆகும். So here you can see content library. So content library ல இருந்து you will get 100+ reference book, okay? So இந்த டைம்ல உங்களுக்கு question பண்ணனும் and content again verify பண்ணனும் நல்லா இருந்தா so content library ல we have lots of physics ஓட book இருக்கு, chemistry ஓட book இருக்கு, biology ஓட book இருக்கு and So you can see here my test, okay? My test la pona you can see live and upcoming test, okay? Daily test irukum. So ungalku paakalam full test da. And here if you missed any test, so yes, I missed lots of tests, okay? So yes, I am doing this test, okay? So attempt now pannite. So start test, okay? Chemistry and physics, biology oda full mock test da irukum because in the few days like we have only like 20 days da irukku. So in the 20 days la maximum question பண்ணனும், okay? Maximum question பண்ணனும், that is very important, okay? Question பண்ணா மட்டும் தான் உங்களோட mark increase ஆகும். Again and again நீங்க content பண்ணிட்டேனா உங்களோட mark negative effect ஆகும், okay? So yes, here you can see, yeah, it's physics. So I'm randomly writing. So tell me your answer, okay? Then I will mark that one. Tell me what is the answer, Ada? I know you don't know this answer. Come on, what is the answer? Happy afternoon, yeah. Malakshmi. Performance. So yes, here you can see next or So here I'm giving random answers and end test. Okay, end test panna. So yes, so total 180 question irundhudu. So number of questions, evlo question answer பண்ணிட்டேன், not answer evlo not answer பண்ணிட்டேன், எல்லாமே இருக்கு. So just submit பண்ணும்போது உங்களுக்கு leader board பார்க்க முடியும். Okay, so உங்களுக்கு leader board பார்க்க முடியும். Okay, yes, I got 0 marks. So here, yeah, and here you can see leaderboard. Okay, leaderboard proper இருக்கு. இவ்ளோ students, okay, here you can see leaderboard ஓட ஒரு சின்ன பார்ட் மட்டும் தான் இருக்கு. So இவ்ளோ students என்ன இந்த டெஸ்ட்ல 631 எடுத்திருக்கு, like 619 எடுத்திருக்கு. So உங்களுக்கு உங்களை அனலைஸ் பண்ணலாம். ஓகே, அதர் ஸ்டூடெண்ட்ஸ் வச்சு உங்களை செல்ஃப் அனலைஸ் பண்ணலாம். எஸ், எனக்கு இவ்ளோ கிடைக்குது இந்த டெஸ்ட்ல, so அதர் ஸ்டூடெண்ட்ஸ்க்கு இவ்ளோ கிடைக்குது. so உங்களுக்கு ஜஸ்ட் கம்பேர் பண்ணலாம். ஓகே, so எஸ், நார்மலி இந்த லைக் டெஸ்ட் டஃபா இருந்தா average range என்ன ஒரு 500 இல்லனா below 500 அந்த ரேஞ்ச். ஓகே, இல்லனா 500 to 600 அந்த ரேஞ்ச் தான் இருக்கு. so உங்களுக்கு ரொம்ப மார்க் லோ ஆயிடுச்சுன்னா yes you can okay yeah. so இது ஆக்சுவலி என்னோட லெவல். ஓகே, செல்ஃப் அனலைஸ் பண்றதுக்கு இது ரொம்ப யூஸ்ஃபுல் தான். ஓகே, so yes, so here you can see பிசிக்ஸ்ல, கெமிஸ்ட்ரியில அண்ட் பயாலஜில எவ்வளவு டாப்பர்ஸ் இருக்கு, எவ்வளவு மார்க் எடுத்திருக்குன்னு உங்களுக்கு இங்க இருந்து ப்ராப்பரா பார்க்க முடியும். ஓகே, எஸ் yes, then we can start our session. So guys, இப்போவே போய் join பண்ணிக்கோங்க. So guys, did you join? ஹரி பிரசாத், ஹரிஹரன் எல்லாரும் ஜாயின் பண்ணிட்டேயா? பிகாஸ் இவ்ளோ ஃப்ரீயா கிடைக்குது உங்களுக்கு. ஓகே, so ஃப்ரீயா கிடைக்குது மீன்ஸ் யாரும் இது தராது. ஓகே, ஃப்ரீயா 100 ரெஃபரன்ஸ் புக் எல்லாம் யாரு கொடுக்கும்? nobody will give. ஓகே மேம், சாப்பிட்டீங்களா? so joined. okay, now you very good. so yes ma'am, Hariharan, so you joined, done. okay, so then we can start our session. so நாம இன்னைக்கு எடுக்க போறது, so I will teach you 11th organic chemistry. so we know that organic chemistry is very important, so I will teach you 11th organic chemistry today. so 11th organic chemistry la நமக்கு தெரியும் chemistry ஓட organic chemistry ஓட பேஸ் தான் 11th ஆர்கானிக் கெமிஸ்ட்ரியில இருக்கும். ஓகே, கெமிஸ்ட்ரியோட பேஸ் தான் 11th ஆர்கானிக் கெமிஸ்ட்ரியில இருக்கும். so yes, we can start with GOC. yeah, I think it's visible allada. so when you consider chemical reaction, what is chemical reaction means? so I will write chemical reaction. what is chemical reaction? what is chemical reaction ada? what is chemical reaction? just a second. so tell me, what is chemical reaction? what is chemical reaction? I will check. my skin is little bit oily, not little, it's very much oily. okay, I will show you. okay, I will show you, no issue. okay, so you can open the library. okay, yes, it is possible. Mukund, yes Mukund, you can access library books also. yes, so tell me guys, what is actually chemical reaction? tell me quickly. ada sollada. what is chemical reaction? breaking and making bond. okay, very nice. so actually chemical reaction means, yes, very good, breaking and formation of bond. breaking and making of formation. I'm writing formation. okay, so formation of new bond. okay, formation of bond and breaking of bond. so in this session, okay, in GOC we are actually discussing about breaking of bond. okay, in GOC we are discussing about sollada, ennada Hari, Old bond break by formation of new bond. Oh, okay. Okay, so chemical reaction means breaking and formation of bonds. So now normally we are discussing about breaking of bond. Okay, breaking of bond. Okay, breaking bond. So when you consider breaking of bond, actually there is two different type of breaking of bond. Okay, so one is homolytic cleavage. Homolytic cleavage. Another one is heterolytic cleavage. Homolytic cleavage. Another one is heterolytic cleavage. So everyone, you please smash the like button, okay? So old bond by forming new bond. I can see 90s bond break up and gens bond form. Oh, really? So yes, homolytic breaking and heterolytic breaking. Okay, so homolytic cleavage or heterolytic cleavage we can say. So what is guys homolytic cleavage or homolytic bond breaking? Homolytic bond breaking na enada? Illana homolytic cleavage na enada? So here you can see inga sigma bond la breaking nadakudhu. Okay, you can see inga sigma bond la breaking nadakudhu. So here I am writing AB. Okay, so AB oda bond da idu. So A is sharing one electron and B is also sharing one electron in this bond. Okay, so mutual sharing, and it is a sigma bond. Okay, it is a sigma bond. Then what will happen? So what is homolysis cleavage? While bond breaking time, so here this A will, okay, this A will take A order bond. A will take this bond and B will take this bond. So what is the product of homolytic cleavage? So it is very simple. A free radical and B free radical or neutral atoms will form. Okay, only neutral atoms will form. Okay, A free radical and B free radical. Okay, neutral. Yes, mutual sharing of electron. Very good. Mutual sharing. So here you can see while bond breaking time, you can see equal distribution of electrons. Okay, energy I'm saying equal distribution of electron. Okay, equal distribution of electron. So what will be the product? That is free radicals. Okay, free radicals. So I hope it's clear. So bonding, okay, bonding, sigma electrons are equally distributed between bonding atom so that electrically neutral intermediate. This is actually what is this? Intermediates. Okay, this is actually intermediates will form. Electrically neutral intermediates will form. I hope it's clear. Then what about heterolytic cleavage? So when you consider here also, generally I am taking AB. Okay, So A is sharing one electron and B is also sharing one electron. Okay, here A is sharing one electron and B is sharing one electron. While bond breaking time, what will happen? So I just want to add one more point. The electronegativity of B is, okay, electronegativity of B is more than electronegativity of A. So guys, what is actually electronegativity in sonna enna? Tell me in the chat box, what is electronegativity? What is electronegativity? Come on. Ganesha Murthy, Shweta, Ramya. Come on guys, what is electronegativity? What is electronegativity? It's not moving. Chat. Attraction towards electron. Unequal distribution of electron. That is electronegativity. Seriously. Electron gain. So here I can see 2026 NEET students. Okay. Tendency of atom to attract electron towards chemical bond. Yes, very good. So what is electronegativity means? It is the ability of an atom to attract shared pair of electrons. So here I just mentioned electronegativity of B is more. Okay, electronegativity of B is more. That means, so this B will attract the shared pair of electron. Okay, B will take the 2 electron. Yes, Navya said yes, I noticed. I read that comment. Okay, so here B is electronegative, more electronegative. Then what will happen? B will take this 2 electron. Okay, then what will form? Similar. So here you can see A plus and B minus. That means cation and anion will form here. Okay, cation and anion will form here. I hope it's clear. So what will be the product of heterolytic bond breaking? Cation and anion. So I am taking carbon. Okay, I am using carbon. So this is carbon, hydrogen, hydrogen, hydrogen. And this is a group G. Okay, this is a group G. What is the speciality of group G? What is the speciality of group G? Electronegativity of G is more than electronegativity of carbon. Electronegativity of carbon. So tell me guys, what is the product? What will be the product? What will be the product? You can write the product in the chat box. I will check. B cation, A anion. Yeah. Here B cation, A anion. Correct. Here I can see carbocation is formed. Okay. Carbocation is formed. Okay. So carbocation means here I am writing. And what will be the next product? G minus, yes, G minus will form. Okay, so carbocation, so this is carbocation, guys. Carbocation and G minus. That means we can say anion. Okay, carbocation and anion is forming. Okay, so here G is anion. Okay, I hope it's clear. So we can assume that I will give you one more molecule. So electronegativity of C is more than electronegativity of G. Okay, we can consider another molecule, that is Cg. Okay, so this is second one. Okay, this is second one. So tell me what will be the product of this molecule? What will be the product of this molecule? Come on down. What you will get? So here I can see answer. Carbanion. Carbanion is formed. Yes, very good. Prem, Joshua, Tanya. Yes. So it's very simple. Carbanion will form. Okay, 1, 2, 3. Anion plus G plus. Okay. I hope it's clear. Clear, do you have any doubt how the carbanion form? How this carbocation form? So actually, this carbocation, this carbanion, and this carbon free radical is actually intermediate. Okay. This is actually intermediate. I hope it's clear. Clear Aleda? Clear Aleda? Yada doubt irukka? No ma'am, all paka. Okay then. So I hope it is clear. So when there is some important point. Okay, there are some important points. So the first point is any covalent bond can break in both homolytic and heterolytic manner. So when you consider any of the covalent bond, covalent bond can break both homolytic and there is no special condition or nothing. Okay. So heterolytic bond breaking takes place in polar solvent. Okay. Heterolytic bond breaking takes place in polar solvent, and then homolytic bond break will takes place in either gaseous phase or in non-polar solvent. Okay. So when you consider bond energy, what is bond energy? Bond energy means minimum energy required to break the bond. Okay. So when you consider a bond, okay, AB bond, okay, if you are giving less energy, it is here you can see. If you are giving less energy, okay, if you are giving less energy, we can't break this bond. Okay, it should have a minimum energy. Okay, we should give it minimum energy to break this bond. Okay, so below that we can't break this bond. Okay, if you are giving below the energy, where is Gopika ma'am? Gopika ma'am will take class at 6 o'clock. Okay, so you have Gopika ma'am at class at 6 o'clock. Okay, yes. Gopika ma'am oda class irukku ungalku 6 o'clock ku. Okay allada? Yes. Yes, 6 ku ungalku Gopika ma'am oda class irukku. Okay, so adukku munadi finish. Okay, Gopika ma'am irukkuda. Yes, no worry. Okay, so when you consider electron displacement, என்னடா electron displacement னு சொன்னா, so normally ஒரு bond form பண்ணும்போது bond ஓட centerல தான் 2 electrons இருக்கணும். Okay, because A is giving 1 electron, B is also giving 1 electron, so ரெண்டு பேருமே electron share பண்ணும்போது, so electron ஓட exact place என்ன, அதோட between. Okay, in between means centerல தான் இருக்கணும். Okay, அந்த bond ஓட centerல தான் இருக்கணும். But அந்த electron actually displacement இருக்கும். Okay, centerல இருக்க வேண்டிய electron என்ன, maybe A கிட்ட போகும் இல்லனா B கிட்ட போகும். Okay, இல்லனா எங்கயாச்சும் போகும். Okay, so அதுதான் actually electron என்ன placementல இருக்கிற difference இல்லனா arrangementல இருக்கிற என்ன அதுதான் electron displacement. Okay, so chinna arrangement. So when you consider electron displacement, it is actually two types. One is permanent effect. Okay, one is permanent effect, another one is temporary effect. Okay, when you consider permanent effect la inductive effect, resonance effect or mesomeric effect, hyperconjugation. So idella most important resonance da, most important resonance. So adukapra hyperconjugation, adukapra inductive effect. Okay, most important ana என்ன permanent effect da resonance effect. Okay, and when you consider temporary effect NEET oda syllabus la illa. Okay, so just temporary effect irukku. So adu for example da electromeric effect, and another one temporary effect is inductomeric effect. Okay, okay, Gopika ma'am means Kanna. Okay, I will say. Okay, நான் சொல்றேன் கோபிகா மேம் கிட்ட. சோ அது ஆக்சுவலி ரியா இது ப்ராப்பரா ஸ்டடி பண்ணணும். ஓகே, சடனா இதுதான் கட் ஆஃப் அப்படி சொல்ல முடியாது. ஓகே, ப்ராப்பரா ஸ்டடி பண்ணிட்டு இல்லனா ப்ராப்பரா ரிசர்ச் பண்ணிட்டு ஐ வில் டெல் யூ. ஓகே, வெட்டினரியோட கட் ஆஃப் எவ்வளவு வருதுன்னு. ஓகே, I will anyway I will upload a video. Okay, so அதுக்காக please show here slide. Okay, now okay, clear alle Ganesh Murthy? So nama permanent effect தான் நாம படிக்க போறது. permanent effect ல important resonance தான், but we are starting from inductive effect. First inductive effect, அதுக்கப்புறம் hyperconjugation, அதுக்கப்புறம் resonance effect. Okay, clear alle? 1 minute. Yeah, take screenshot if you want. If you want to take screenshot, take screenshot. I hope it's clear alle. Shri ma'am is famous for sollada ennada. Okay, so first we are discussing about inductive. Okay, inductive effect. So what is inductive effect? When you consider inductive effect is actually two types. Okay, you can see minus I effect. Inductive effect normally you will say I effect. Okay, inductive I effect. So when you consider inductive effect, it is actually two types, minus I effect and plus I effect. What is inductive effect? So it is also permanent displacement of electron. Okay, permanent displacement of sigma electron, not pi electron. Okay, so it is the permanent displacement of sigma electron in a covalent bond because of any atom or group known as I effect of that. So எதனால அந்த எலக்ட்ரானுக்கு டிஸ்பிளேஸ்மென்ட் வருது, அதுக்கு மெயின் ரீசன் தான். ஓகே, அந்த எலக்ட்ரானுக்கு டிஸ்பிளேஸ்மென்ட் வர்றதுக்கு மெயின் ரீசன் என்னன்னா அதோட அங்க இருக்கிற குரூப்போட. ஓகே, அந்த G group மேம் temporary effect summer months, while the permanent effect is lifetime commitment. You are not ready for it. Heda எனக்கு ஆப்பு. Okay, so here you can see minus I effect. Okay, first we are discussing about minus I effect. Okay, so what is minus I effect? So 1 2 3 4 carbon consider பண்ணலாம். இங்க ஒரு group G group இருக்கு. Okay, here you can see a G group is there. Okay, maybe atom or a molecule. Okay, so maybe the atom or group. Okay, group of atom. Mama. So what will happen? The speciality of G is, okay, the speciality of G is actually G. The speciality of G is actually what is G? What is G? What is G? It is the electron withdrawing group. Electron withdrawing group. Okay, it is the electron withdrawing group. Okay, it is a electron withdrawing group. What is electron withdrawing group? What is electron withdrawing group? Withdraw electron. Yes, yes, electron withdrawing group. So now what will happen? The speciality of G is actually it will attract this electron. Okay, so it will attract this electron. So normally central irukka vendiya electron. Normally central irukka vendiya electron ennada G pakkathila irukum. Okay, G pakkathila irukum. Why? Because it is an electron withdrawing group. Okay, so then what is the charge of G? Charge of G is delta negative. Okay, why it is delta negative? So complete and the one electron yaar edukala? G edukala. Okay, complete kadikala. So adoda proper place la irundhu konjam G oda pakkathila irukku. Okay, partial negative charge. Okay, here you can see delta negative. Okay, partial negative charge. So when you consider carbon, it is actually partial positive charge. Okay, partial because carbon is giving electron. So one more point is there. So only in the carbon mattunda positive partial positive charge irukuma illa. So in the carbon irukku. So partial positive charge. Again delta positive. So delta positive means small positive. Delta positive means small positive. Okay, small positive. And delta positive means small positive. Okay, so inga varumbodhu positive charge kammi agudhu. Okay, positive charge kammi agudhu. Up to third carbon varaikum da inda charge irukku. Fourth carbon la irukumbodhu actually we can neglect that charge. Okay, we can neglect that charge. Okay, so here you can see atom or group which withdraw electron of the sigma bond toward themselves as compared to hydrogen are said to have electron withdrawing group or electron attracting or minus I group. Okay, clear alle? Yadacha doubt irukka? G can be halogens. Yes, G can be halogens. Yes, correct. G can be halogens. Not only halogen, there is some group. Okay, clear, ma'am? No, Navya, chocolate girl. I forget. I called my mom and I said, Amma, you didn't give 5 rupees for chocolate. So நான் ஸ்கூல்ல எல்லாம் படிக்கும்போது எனக்கு ஒரு 5 rupees கிடைக்கல சாக்லேட்டுக்கு. இப்போ ஸ்டூடெண்ட்ஸ்க்கு எல்லாமே 1000 rupees கொடுக்குது சாக்லேட்காக. So sad. எங்களோட லைஃப். Okay, 90s kids ஓட லைஃப். Okay, so here you can see this is not plus I effect. It is minus I group. Minus I group. Okay, minus I group. Okay, so இப்போவே by heart பண்ணி வெச்சுக்கோங்க. Okay, yeah. Yes, 1000 rupees chocolate girl. So here you can see NF3 plus and after that NR3, NH3, NO2, CN carboxylic acid and adukapra halogen varudhu, OR varudhu, OH varudhu, adukapra SP, that means triple bond. NH2, okay, NH2 inge NH3 irukku, confusion aga koodadu. Okay, so here you can see NH2, here you can see NH3. So and NH2 benzene and after that sp2. Okay, clear alle? Clear? எடா உங்களுக்கு தமிழ்ல வேணுமா இங்கிலீஷ்ல வேணுமா? இங்க எல்லாரும் ஓகே தான். ஃபேண்டம். Clear, ma'am? Okay. So இது by heart பண்ணியே ஆகணும். We don't have other option. Okay. Clear. எடா ஹரிஹரன், you don't know Malayalam. You are asking to ChatGPT. So now you want Malayalam class. So next is plus I effect. So when you consider plus I effect, same ada. So C, and here you can see a group G. What is the speciality of group G? What is the speciality of group G? It is a electron donating group. Okay, it is a electron donating group. This is inductive pulling electron always faster than this. Chat sentences, it's being pulled away by chocolate drama. So electron donating group. That means this group or maybe atom is ready to donate electron. Okay. So that group or atom is ready to, yes, I am ready to give electron. Okay. So that is G. Okay. So what will happen? G is ready to give electron to, to carbon here. Yes. So what is the charge of group G? It's giving electron. So positive character. So delta positive. Here it is delta negative. Here double delta negative. Here it is triple delta negative. I hope it's clear. Eda clear alle? Manasilayo ma'am? Yes, manasilayi. Yes, manasilayi. Okay, allada. Okay. So next step. So here you can see plus I group order groups. Okay, plus I group order. So here you can see CH3 minus, NH minus, O minus, CO2 minus, and here you can see it is tertiary and secondary, primary, and here you can see after that isotopes. Okay, உங்களுக்கு isotopes பார்க்க முடியும். So isotope அதுவும் ஹைட்ரஜனோட isotope. Okay, ஹைட்ரஜனோட isotope மட்டும் தான் பார்க்க முடியும். Tritium, deuterium and hydrogen. Tritium, deuterium and hydrogen. I hope it's clear. Okay, this is protium. Okay, I hope it's clear, Aleda. Then we are moving to application of inductive effect. Okay, application of inductive effect la main 4 application da irukku. Okay, inductive effect oda application check பண்ணும்போது when is bioclass? Bioclass start from 6 o'clock. Okay, today evening 6 o'clock da irukku. So phantom, yes, phantom. Where is phantom? Yeah, phantom ma'am. Yes da, yes phantom. What is your name? Now we are 6 p.m. Yes. So I hope it's clear. So when you consider inductive effect, okay, inductive effect consider பண்ணும்போது அதோட application தான் 4 points இருக்கு. Okay, அதோட applicationல first one is stability of carbocation and stability of free radical. Okay, stability of carbocation and stability of free radical. And next is stability of carbanion. Okay, so guys, when you consider stability of carbocation and stability of carbon free radical, adoda rules actually similar, same da. Okay, yes guys, quickly smash the like button. Yes, she know, she or here, that I don't know. So yellow like side jada 150 plus da nammaloda target. Okay. Okay. So yes. So இது ரெண்டுமே same similar rules தான் follow பண்ணும். And here it is stability of carbanion. Next is acidic strength and basic strength. Okay. So இது மூணு தான் இம்பார்ட்டண்டா வருது. Basic strength அவ்வளோ இம்பார்ட்டன்ட் இல்ல, பட் அதோட rules எல்லாமே பார்த்து வச்சுக்கோங்க. Okay. So yes. So here is the first one. So that is stability of carbocation and carbon free radical. Okay, so stability of carbocation and carbon free radical. So adil actually 3 rules irukku. So the first rule is actually electronegativity of carbocation or carbon free radical increases stability of carbocation, increases stability of carbocation and carbanion decreases. Okay, okay, so if, okay, I will tell you, when you consider electronegativity, okay, electronegativity is directly proportional to S character, we know that. Okay, electronegativity is directly proportional to S character. So here electronegativity is inversely proportional to stability of carbocation or carbon free radical. Okay, stability of carbocation or carbon free radical, that is electronegativity is inversely proportional to, if electronegativity increases, stability of carbocation or carbon free radical decreases. Okay, it is inversely proportional. Okay, so here you can see that. So what is S character? So we know that hybridization, sp hybridization is there, sp hybridization is there, and sp2 hybridization is there, and sp3 hybridization is there. So we know that here the S character is actually 50%, and when you consider sp2 la evlo percentage irukku, that is actually 33.3%, and when you consider sp3 la S oda character is actually 25%. Okay, so here this is the S character or S percentage of sp and sp2 and sp3. So நமக்கு தெரியும் S character increase ஆகும்போது electronegativity decrease ஆகும். Okay, S character increase ஆகும்போது electronegativity decrease ஆகும். Not S character. S character electronegativity directly proportional தான். Okay, ரெண்டுமே என்ன increase ஆகும். Okay, so if its character increases, electronegativity also increases because it is directly proportional. Okay, so when you consider in an SPT, stability of carbocation or carbon free radical. So sp sp2 sp3 la எழுதும்போது எப்படி எழுதணும்னா, so stability ஜாஸ்தியா இருக்கிறது sp3 க்கு தான். sp3 stability is more than sp2 then sp stability, because here sp3 ஓட stability தான். Okay, carbocationல sp3 ஓட stability தான் ஜாஸ்தியா இருக்கும். Why? Because here the percentage S character is less. Okay, here you can see 25% தான் இங்க S character இருக்கு. So S character is less, so because stability is more. Okay, I hope it's clear allada. I hope it's clear. Hi Suki, yes Suki. Hi Suki, Ganesha, Krishna, Suki, Abhimanyu. So this is the first rule. Okay, this is the first rule. If first rule fails, okay, first rule fail ஆனா மட்டும்தான் நீங்க என்ன செக் பண்ணனும், second rule check பண்ணனும். So here you can see second rule. What is second rule? When you consider primary, secondary and tertiary carbocation, which carbocation is more stable? When you consider primary, secondary and tertiary carbocation, which carbocation is more stable? Obviously tertiary carbocation is more stable, then secondary, then primary. Least stable is primary. Okay da? So if first rule and second rule fail, then you can check third rule. Okay, then you can check third rule. What is third rule? So it is very simple. Stability of carbocation is directly proportional to plus I group and inversely proportional to minus I group. Clear allada? Yeddachu doubt irka in the stability of carbocation and carbon free radical la? I hope it's clear. Then I will give you a question. Okay ma'am. Ganesh Murthy. இந்த டைம்ல question maximum பண்றது ரொம்ப important தான். Okay, you should do maximum question. So tell me the answer. Time management ரொம்ப 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 important தான். Okay, ஒரு question பண்ணனும்னா we know that 2026ல ஓகே ஆக்சுவலி நீட்டோட டைம் இன்க்ரீஸ் பண்ணிருக்கு. ஓகே உங்களுக்கு 15 minutes போனஸா கிடைக்குது. சோ இந்த 15 minutes எல்லா ஸ்டூடெண்ட்ஸ்க்கும் கிடைக்குது. ஓகே இந்த 15 minutes எல்லா ஸ்டூடெண்ட்ஸ்க்கும் கிடைக்குது. சோ நீங்க இந்த 15 minutes ப்ராப்பரா யூட்டிலைஸ் பண்ணணும்னா மேக்ஸிமம் क्वेश्चंस பண்ணணும். ஓகே மேக்ஸிமம் क्वेश्चंस பண்ணணும். சோ அதனால for that we are introducing here you can see description la pona you can see get Nambikai re-NEET 2026 AITS. Okay, all India test series. So idu click panna Amazon la da உங்களுக்கு லிங்க் இருக்கும். சோ இதோட ஸ்பெஷாலிட்டி என்னன்னா ரீநீட்டுக்காக ஸ்பெஷலா கிரியேட் பண்ண क्वेश्चंस. ஓகே சோ ரீநீட்டுக்காக ஸ்பெஷலா எடுத்த क्वेश्चन தான். பிகாஸ் சடனா நீட் எல்லாமே சேஞ்ச் பண்ணிட்டு சோ அந்த நீட் பேட்டர்ன்ல ப்ராப்பரா ரீநீட்டுக்காக create பண்ண question தான். So you will get almost 2520 question. Okay, this contain 2520 question plus இதுல 14 complete mock test இருக்கு. So உங்களுக்கு அந்த சேம் அட்மாஸ்பியர்ல இருந்து OMR ல மார்க் பண்ணும்போது okay, so you will get confidence. Okay, இல்லனா OMR ல ஏதாச்சும் OMR ஷீட்ல ஏதாச்சும் மிஸ்டேக் வர்றதுக்கு எல்லாமே சான்சஸ் இருக்கு. சோ அந்த கம்ப்ளீட் எக்ஸாம் அட்மாஸ்பியர்ல ஒரு எக்ஸாம் ஒரு மாக் டெஸ்ட் எழுதும் போது உங்களுக்கு கொஞ்சம் கூட கான்ஃபிடன்ஸ் கிடைக்கும். ஓகே சோ ஹியர் யூ வில் கெட் என்ன 14 ஃபுல் லெங்த் மாக் டெஸ்ட் பிளஸ் 20 OMR ஷீட். ஓகே சோ ப்ராப்பர் உங்களுக்கு 20 OMR ஷீட் இருக்கும். சோ அப்போ உங்களுக்கு ஆட்டோமேட்டிக்கலி என்ன ஃபில் பண்றது ஈஸி ஆகும். ஓகே ஃபில் பண்றது ஈஸி ஆகும். சோ பிகாஸ் நீங்க டைரக்டா என்ன எக்ஸாம் சென்டர்ல போகும்போது டெஃபினெட்லி பேனிக் ஆகும். சோ அதுக்காக அதை அவாய்ட் பண்றதுக்காக சோ உங்களுக்கு இந்த காம்போ கிடைக்குது. சோ இந்த காம்போல you will get 2520 questions. so இந்த 2520 question உங்களோட ரீநீட்டுக்காக ஸ்பெஷலா ப்ரிப்பேர் பண்ண questions and you will get 14 what you will get 14 full length mock test 20 OMR sheets இருக்கும். இதோட price is actually 549 rupees. okay and என்ன so yes and இது actually Amazon ல இருந்து கிடைக்கும். so 5 to 6 days ல உங்களுக்கு home delivery பண்ணும். okay so yes இது எல்லாமே சீக்கிரமா யூஸ் பண்ணிக்கோங்க. so tell me what is the correct answer. Tell me guys what is the correct answer. Just a second, I can't see answer. Can't see your answer. Can you write the order? Can you write the order? Phantom bro, hi. Phantom bro, hi. Yes, we can write the order. So we know that NO2, no, NO2. So when you consider NF3 plus what I am writing, NF3 plus and NR3 plus and NH3 plus NO2CN and after that NO2CN, after that X is there. So yes, NO2 yada. So what is the question? Which of the following has minimum I effect? Okay, so here fluorine is there. So when you consider NR3 plus and it is NO2 is here and COO, yes, COOH is there. CN, yes, after the COOH then X. Correct. COH is there then fluorine. Your correct answer is option 3 only. That's very good guys. Sushmita, yes Sushmita. So then I will give you another question. Come on, it's very easy. Very good, halo alkene, nice. So did you Did you do any mock test or something? நல்லா இருக்கே, என்ன நல்லா இருக்கேடா? I forget your name. Jitendra. Tangamalai, I forget your name. Real name. Yes, you guys are saying 3CL. So let me check. Hydrolysis of propane gives methyl and ethyl free radical. Hydrolysis. Okay. So methyl carbocation and ethyl free radical. So guys, it is hydrolysis. Okay. Hydrolysis means what will be the product? Hydrolysis. What will be the product? So we know that either you will get carbocation or carbanion or anion or cation. Okay. So here you can see. From first option methyl and ethyl free radical. So you will get free radical in homolysis. Okay, not in hydrolysis. Methyl carbocation and ethyl free radical formation. No. Methyl anion and ethyl carbocation. Yes, correct answer is option 3. Very good guys. So okay guys, உங்களுக்கு biology class actually 7 o'clock தான். Okay, so 6 இல்ல 7 o'clock. Okay, so yes, biology class இருக்கு. So next question. Yes. So guys, உங்களுக்கு actually நான் 6 னு சொன்னேன் biology class. உங்களுக்கு 6 க்கு இல்ல biology class, 7 க்கு தான் biology class. Okay. Yes. Cool. It is nice and easy. So come on guys. In the answer. Find the correct order of stability of carbocation. Okay. So tell me. Trying to find stability order here feels like pointless as the carbocation steal electron from those greedy chlorine atom. How you are getting this? ChatGPT or Gemini or which AI you are using? Or your brain? So tell me guys, what is the correct answer? You guys are saying C. Again C. Okay, let me check. So find the correct order of carbocation stability. Okay. So when you consider stability of, so I'm writing stability of carbocation is directly proportional to. So we know that some rules. Okay. So the first rule is S character. So we can apply here S character, electronegativity, nothing. And second group, primary, tertiary and secondary. So here also we can apply primary, secondary, tertiary. And then we can check a third rule. So carbocation, stability of carbocation is directly proportional to plus I group and inversely proportional to minus I group. Let me check. Plus. It's already, no. It is directly proportional to plus I and inversely proportional to minus I. Here you can see third rule. Okay. So yeah. So we can apply third rule here. So if you are checking third rule here, we should apply one more method. Okay. That is DNP method. So what is DNP? First you should check distance, then you should check number, then you should check power. Okay, first priority is for distance. Okay, when you check distance, okay, stability of carbon. So when you consider chlorine is actually minus I group. Okay, minus I group. So minus I attached to a Carbocation means stability decreases because it's inversely proportional. Okay, stability decreases because it's inversely proportional. Okay, it is inversely proportional. Increase ஆகுது. Okay, distance என்னடா increase ஆகும்போது carbocation. So இங்க பார்த்தா தெரியும் 1 2 3 4th கார்பன்ல குளோரின் இருக்கு. இங்க செகண்ட் கார்பன்ல குளோரின் இருக்கு. இங்க தேர்ட் கார்பன்ல குளோரின் இருக்கு. Okay, so fourth கார்பன்ல குளோரின் means fourth carbonல chlorine, fourthல தான 1 2 3 4, here 1 2 1 2 3. So fourth carbonல chlorine means distance is increased. Okay, so minus iode distance increase ஆயிடுச்சு. So minus iode distance is more means stability is more. So second third one and third second இருக்கு. இது second carbonல, இது third carbonல. Next is 1 then 2. So what will be the correct answer? One. Correct answer is option 3. Correct. Buffering ma'am. Seriously. எல்லாருக்கும் buffering இருக்காரா? இல்லனா உனக்கு மட்டுமா? So when you consider stability of anion. Stability of anion is just opposite of stability of carbocation. Okay. So carbocationல என்ன சொல்லிருக்கோ அதோட just opposite point தான் இங்க இருக்கு. Okay, here you can see as electronegativity increases, stability of carbanion increases. Okay. So next second point enna, so நாம carbocation ல சொன்னது more stable is tertiary, then secondary, then primary. So inga actually primary is more stable, then secondary, then tertiary. And when you consider third rule, okay, first and second rule 3 la adichana, we can check third rule. What is third rule? Stability of carbanion is directly proportional to minus I and inversely proportional to plus I. Okay. And priority order is actually D and P, distance, number and power. Then I will give you one question you can write. Okay, before that I just want to add one more point. Next application of inductive effect, that is acidic strength. Okay, what is acidic strength? We know that when you consider acid, okay, here you can see HA. Okay, HA water la dissolve பண்ணும்போது we will get H plus. Okay, H plus and A minus. Okay, so H plus and A minus. So இங்க இந்த acid stable ஆகணும், இல்லனா strong acid னு எப்ப சொல்ல முடியும்? So இங்க இருந்து H plus போனதுக்கு அப்புறம் இந்த A minus should be stable. Okay, இந்த A minus stable ஆ இருந்தா மட்டும்தான் we can say that this HA is a strong acid. Okay, we can say that it is a strong acid னு சொல்ல முடியும். Okay, I hope it's clear அல்லடா? So இதுதான் concept. Okay, so acidic strength or acid or stability of conjugation ion. Okay, that stability conjugation ion is this. Okay, if conjugation ion is stable means we can say acidity is more. Okay, acidity is more. And we can also say that acidity is directly proportional to electron withdrawing group and inversely proportional to electron donating group. What is electron withdrawing group means? That is minus I and inversely proportional to plus I. Okay, I hope it's clear. Then I will give you a question. Come on. Shweta. So tell me guys, what is the correct answer? So everyone quickly smash the like button. I said ma'am, very good Shweta. Jahi, now fine ma'am. Now it's buffering. It was okay. Now clear allada. Screen, blur screen. Really? No da. Brain processing time ah? Illana. Hello guys, tell me what is the correct answer? Clear alle? Any issue? Are you facing any issue? Guys, are you facing any issue? 3. Suki Abhimanyu is saying 3. Let me check. Any other answer, guys? Your brain. I think your brain is processing. You're taking lots of time. Okay, you're taking lots of time. Kevin, Samuel. Now all perfect. No issues. He's saying chumma. So, before screen was blurred. Okay, that I don't know. I checked. I can't see. Okay, so here you can see order of Ka. What is Ka means? Acidic strength. Okay, so Ka means it is acidic strength. So Ka is inversely proportional to pKa. Okay, maybe they will ask Ka or maybe they will ask pKa. Okay, so Ka and pKa. Okay, Ka is inversely proportional to pKa. So just a second, I want to write order of K in the following compound. So here we know that it is acidic strength. Okay, we know that acidic strength is acidity. Acidity is directly proportional to minus I and inversely proportional to plus I. Okay, inversely proportional to plus I. So here you can see it will form H plus and this will form minus. H plus minus, H plus minus, H plus minus. So here you can see this is actually minus I. This is actually minus I group. This is also minus I group. This is also minus I group. So first you should check if you're checking the strength, acidic strength or something. Okay. So you should check distance, then number, then power. So here also we should check distance first. Okay, what is distance? So here you can see one first carbon, one. So 1, 2, second carbon contain. This is also 1, 2, second carbon contain. This is 1, 1. So yes, 1 carbon. Okay, so first carbon contain 2 chlorine for this molecule, and here first carbon contain NO2 for this molecule. Okay, so first one is distance. When you consider distance, distance le inga 1 da irukku. So 1 irukkuradhu 2 molecules. Okay, so then second one is number. If number of molecule is more, means stability is also more. Okay, that depends. Okay, that depends. So எப்பவுமே number more means stability more னு சொல்ல முடியாது. Okay, so அது acidic strength இல்லனா minus I plus I character எல்லாத்தையுமே depend பண்ணும். Okay, yes, here you can see 2 chlorine is there. Okay, conjugation. Okay guys, then we can move to next topic, hyperconjugation. What is hyperconjugation and what is hyperconjugation? So when you consider hyperconjugation, before that, this hyperconjugation is also called no bond resonance, Began-Apple effect, sigma pi resonance. Okay, so this is very important. In the name which NEET question vandirukku. Again loading up. Again loading. Seriously, loading up. Loading. I can see. No da. Hello. No da. Illada. Now clear, ma'am. Okay. Okay. So guys, evlo likes ஆயிடுச்சு 100 likes எனக்கு இப்போ வேணும். So here I can see students are. So Kanjus, you are not ready to like the session, but you're watching the session. Last slide can't able to see, ma'am. Okay, last slide. Okay, now clear, Alada. You explain again, ma'am. Okay, I will explain the question again. So yes, I will explain again. So when you consider acidic strength, means this one, yes, acidic strength. So acidity is directly proportional to minus I and inversely proportional to plus I. So here you can check. So inge எந்த group இருக்குன்னு. Okay. So first we can check எந்த group இருக்குன்னு. This is actually minus I group. இதுவும் minus I group. எல்லாமே minus I group தான். N2 minus I group. So நாம first power check பண்ணும்போது N2 க்கு தான் power. Okay. More power N2 க்கு தான் இருக்கு. But power இல்ல நாம check பண்ணும்போது first you should check distance, then number, then power. Okay. First we can check distance. Okay. So this is a H plus form ஆகும் O minus, and here also H plus O minus, H plus O minus, H plus acid ஆகும்போது H plus form ஆகும்ல. So which acid is more acidic? Okay. So here you can see first carbon contain 2 chlorine. Here also first carbon contain 1 NO2, second carbon contain 2 NO2, and second carbon contain 2 chlorine. Okay. So first DNP rule, first you should check distance. Okay. So first you should check distance. So distance check பண்ணும்போது distance இங்க பக்கத்துல தான் இருக்கு. Okay. And it is directly proportional. Minus I தான் இருக்கு. Minus I பக்கத்துல இருக்கு. And it is, we know that it is directly proportional. So we can write it as so either என்ன இதா இருக்கலாம் இல்லனா இதா இருக்கலாம். So அப்போ எப்படி செக் பண்ணனும்? Second one, number. Okay. You should check number. So we can check number together now. Number. So number check பண்ணும்போது இங்க 2 chlorine இருக்கு, இங்க 1 NO2 மட்டும் தான் இருக்கு. Okay. இங்க 2 chlorine இருக்கு, 1 NO2 மட்டும் தான் இருக்கு. So இதனால more acidic யாரு? Number, more number இருக்கிறது more acidic. So correct answer என்ன? 2 ல தான் இருக்கு. Okay. 2, then we know that it is 1. Okay. இங்கே answer lock பண்ணலாம்ல. So 2 1 வர்றது இது மட்டும் தான். Option 3 மட்டும் தான். So option 3 is the correct answer. Jahi clear? Clear ada? Jahi clear? No, fourth position. இதாடா புரியல. யாரு கேட்டதுடா? மேம் டவுட். chlorine is second in fourth position also la ma'am, second. எடா இது first you should check distance. Okay. First நீங்க distance check பண்ணனும். So இங்க chlorine first carbonல chlorine இருக்கு, இங்க first carbonல NO2 இருக்கு. Okay. First நீங்க என்ன check பண்ணனும்? Distance check பண்ணனும். Then second point தான் number. Okay. So this is very important. Okay. Okay. இது ரொம்ப important. First you should check distance. எவ்வளோ distance வருது? Then you should check number. அதுக்கப்புறம் தான் number check பண்ணணும். So இங்க பாருங்க, first chlorine தான், first carbonல தான் 2 chlorine வருது. Here you can see second carbonல தான் 2 chlorine வருது. இப்போ கரெக்ட்டா? Okay ma'am. Okay, clear. Okay. Then what? Yes, when you consider conjugation. So when you consider conjugation, so conjugation la in the name base பண்ணிட்டு previous year question வந்திருக்கு. Okay. So and in the name in the condition ரொம்ப important தான். So hyperconjugation உங்களுக்கு எங்க பார்க்க முடியும்? Either carbocation, carbon free radical or alkene. உங்களுக்கு carbanion ல hyperconjugation பார்க்க முடியாது guys. Okay, this is very important. Okay. Okay. So yes. So hyperconjugation applicable only in carbocation, carbon free radical and alkene. Okay, இது ரொம்ப ரொம்ப important தான். Okay, இது என்னடா? ரொம்ப ரொம்ப important தான். So இது ரொம்ப important தான். Okay, so இதுக்கு கொஞ்சம் conditions இருக்கு. Okay, hyperconjugation உங்களுக்கு பார்க்கணும்னா கொஞ்சம் conditions இருக்கு. So the first condition is at least one alpha carbon should be there, and that alpha carbon should be sp3 hybridized. Okay, so at least one alpha carbon irukano, and that alpha carbon should be sp3 hybridized. And second point is that alpha carbon should contain at least one alpha hydrogen. Okay, that alpha carbon should contain at least one alpha hydrogen irukano. அப்படி இருந்தா மட்டும்தான் உங்களுக்கு என்ன பார்க்க முடியும், ஹைப்பர் கான்ஜுகேஷன் பார்க்க முடியும். ஓகே, உங்களுக்கு ஹைப்பர் கான்ஜுகேஷன் பார்க்கணும்னா அந்த ரெண்டு கண்டிஷனும் ரொம்ப இம்பார்ட்டன்ட். And here you can see, okay, like few examples we can do. So so you can write find the number of hyperconjugation. Okay, find the number of hyperconjugation. Find the number of hyperconjugation structure. Hyperconjugation structure. So here I am writing hyperconjugation structure. Okay, so how we will calculate hyperconjugation structure? So here you can see that it is a carbocation. Okay, this is a carbocation. So here this is a carbocation. So carbocation la alpha hydrogen evlo irukku calculate pannu. So this is carbocation. So carbocation direct attach panni irukra carbon da alpha carbon. So this is alpha carbon. So this alpha carbon to contain two hydrogen. So that is alpha hydrogen. So hyperconjugated structure is actually 2. Okay, hyperconjugated structure is actually 2. Okay, I don't know da. What is Junko Furuta case? No idea. So I will just take screenshot. Okay, Junko Furuta case. Okay, I will check. Here I can see lots of answers. So just calculate number of alpha hydrogen. So here you can see this is alpha, this is carbocation. So this carbocation is directly attached with two other carbocation. It is secondary carbocation. Okay, so this hydrogen, this carbon contain two hydrogen and this carbon contain two hydrogen. So hyperconjugated structure is actually 1 2 3 4. Clear alle? So if you check here, so tell me, so in the answer enna, third order answer enna? So tell me third order answer enna here? Yes, here I can see lots of answers. Very good guys. Come on. Number of alpha hydrogen, correct? Yes ma'am. So can you tell me the reason? Suki, Abhimanyu and Joshua. Yes, you guys are saying it's 0. Okay. So why it is 0, Ada? Why it is 0? Yes. Ganesh. Guys, why it is here? Why the hyperconjugated structure is 0 here? Why hyperconjugated structure is 0 here? No alpha hydrogen. No alpha hydrogen. Seriously? So here you can see in conditions I just mentioned that at least one alpha carbon should be there, and that alpha carbon should be sp3. Okay, that alpha carbon should be sp3. So here you can see here this is a carbocation. So carbocation is directly attached with this carbon. So this carbon is actually a alpha carbon. So this carbon is actually alpha carbon, but this alpha carbon is actually sp2 hybridized. It is sp2 hybridized. So that is the reason here hyperconjugation is actually 0. Okay, that is the reason here the hyperconjugated structure is actually 0. Okay, then when you check this, okay, you can, I will give it as homework. Okay, do it as homework. Then when you consider this is alkene. Okay, now we discussed carbocation. So now it is alkene. So alkene, so tell me how many hyperconjugated structures are there? Hyperconjugated structure. So hyperconjugated structure you can write in the comment section. Okay, So I will check. Because no alpha hydrogen. Okay. Come on, da. So come on, right. So everyone, you please smash the like button. So guys, in the time நீங்க maximum questions பண்ணனும். Okay, maximum questions பண்ணனும். Maximum அது ரொம்ப important. Okay. So அதுக்காக we are actually giving sources. Okay, so உங்களுக்கு yes ma'am sources தான் கிடைக்கல ma'am. எல்லாருக்கும் இப்போ நார்மலி இன்ஸ்டாகிராம்ல எல்லாரும் சொல்றது அதுதான் மேம். அவ்வளோ சோர்ஸ் இல்ல, பிகாஸ் எல்லாரும் நீட் முடிஞ்ச போதே எல்லாரும் புக் எல்லாமே லைக் எல்லாமே எடுத்து லைக் என்ன அது போயிட்டேன் மேம், அந்த பேப்பர் போயிட்டேன், அது போயிட்டேன், இது போயிட்டேன், லைக் ஷார்ட் நோட்ஸ் இருந்தது. ஸோ எல்லாருக்கும் இருக்கும். ஓகே, ரிசோர்சஸ் ஆல்ரெடி இருந்தது, எல்லாருமே என்ன ஸ்பாயில் பண்ணிட்டேன் எல்லா ரிசோர்சஸும். பிகாஸ் அதுக்கப்புறம் கிளாஸ் இல்லை, நீட் இல்லை, எஸ் நீட் கிராக் பண்ணிட்டேன்னு எல்லாமே ஒரு மைண்ட் செட்ல. ஸோ மோஸ்ட் ஆஃப் த ஸ்டூடெண்ட்ஸும் அப்படி பண்ணியிருக்கு. ஸோ அதனால ஹியர் வி ஆர் கிவிங். ஓகே, ஹியர் வி ஆர் கிவிங் என்ன எங்களோட லைப்ரரி ஆக்சஸ் உங்களுக்காக. ஸோ அதுக்காக நீங்க என்ன பண்ணணும், ஸோ உங்களுக்கு என்ன வேதாந்தோட இந்த சேனல் இந்த செஷனோட டிஸ்கிரிப்ஷன்ல போய் பார்த்தா உங்களுக்கு யூ கேன் see different links. ஓகே, ஸோ அதுல ஃபர்ஸ்ட் லிங்க் இருக்கு, ஜாயின் த ஃப்ரீ ரீநீட் 2026 கிராஷ் கோர்ஸ். ஸோ இது கிளிக் பண்ணா யூ கேன் see this. ஓகே, ஸோ ரீநீட் 2026 கிராஷ் கோர்ஸ் தமிழ்நாடுன்னு பார்க்க முடியும். ஸோ இது ஜஸ்ட் பை நவ் கிளிக் பண்ணுங்க. ஸோ பை நவ் ஆக்சுவலி இது ஃப்ரீ தான்டா. ஸோ டோன்ட் வரி மேம், பை நவ் எல்லாம் கிளிக் பண்ற சொல்றேன்னு. 0 காஸ்ட். ஓகே, 0 rupees தான் இருக்கு, 0 rupees தான் இருக்கு. So don't worry. Okay, so here you can see ReNEET 2026. It's completely free crash course. Okay, it's completely free crash course. So normally என்ன உங்களுக்கு நீங்க யூடியூப்ல கிளாஸஸ் செஷன் பார்க்கும்போது obviously காமெண்ட் செஷன்ல டிஸ்ட்ராக்ஷன்ஸ் இருக்கும். ஸோ உங்களுக்கு ஸ்பெஷலா கெமிஸ்ட்ரி செஷன் பார்க்கணும்னா இந்த கெமிஸ்ட்ரி செஷன்ல போய் லைக் பி பிளாக் இருக்கு, ஜெனரல் ஆர்கானிக் கெமிஸ்ட்ரிஸ் இருக்கு, ஜிஓசி இருக்கு, ஐசோமெரிசம் இருக்கு, ஹலோ ஆல்கீன்ஸ் அண்ட் ஹலோ அரீன்ஸ் இருக்கு. ஸோ உங்களுக்கு இங்க இருந்து அது பிளே பண்ணலாம். ஓகே, ஸோ அந்த வீடியோ இங்க இருந்து பிளே பண்ணி டிஸ்ட்ராக்ஷன் ஒன்றும் வேணாம்னா அது டைரக்டா அங்க போய் பார்க்கலாம். ஓகே, அண்ட் அது மட்டும் இல்லாம யூ கேன் ஆக்சஸ் கண்டென்ட் லைப்ரரி. யாரும் நேத்து லைக் லாஸ்ட் கேட்டிருக்கு. ஸோ கண்டென்ட் லைப்ரரி எப்படி ஆக்சஸ் பண்ணணும்னு. ஸோ கண்டென்ட் லைப்ரரி இருக்கு. So if you want, you can create your own test. Okay, so you can customize your test. Okay, so maybe நீங்க எல்லா டேஸ்லயும் எல்லா கண்டென்ட்டும் படிச்சிருக்க மாட்டேங்க. So maybe உங்களுக்கு ஜிஓசி மட்டும் தான் வேணும், இல்லைன்னா பயாலஜில பர்டிகுலர் சாப்டர் தான் வேணும், அண்ட் லைக் ஏதாச்சும் பிசிக்ஸ்ல பர்டிகுலர் சாப்டர் தான் வேணும்னா so you can customize your own test. Okay, and study with top books. Okay, so here you will get 100+ reference book. Okay, so reference book. Okay, so like we know that. So nama normally match பண்ணி பார்ப்போம்ல, different reference books இருக்கு. So here you can see yes MTG ஓட 30 years book இருக்கு, actually வேதாந்தோட MTG ஓட 30 years book இருக்கு. So yes, இது எல்லாமே உங்களுக்கு ஃப்ரீயா கிடைக்குது guys. Okay, உங்களுக்கு இதோட ஸ்பெஷல் சாப்டர்ஸ். Okay, so உங்களுக்கு வேணும்னா இங்கே சப்போஸ் some basic concepts of chemistry ஓட டெஸ்ட் மட்டும் ட்ரை பண்ணணும்னா so you can do. Okay, cute test இருக்கு. So yes, instructions இருக்கு. So you can start the test. So yes, so உங்களுக்கு ஆன்சர் பண்ணலாம் and they will give you the answer also. Okay, proper ஆன்சரும் உங்களுக்கு கிடைக்கும். ஓகே, so proper ஆன்சரும் உங்களுக்கு அனாலிசிஸும் உங்களுக்கு இங்க இருந்து கிடைக்கும். So guys, yeah, so yes, next is actually InstaSolve. So உங்களுக்கு ஏதாச்சும் டவுட் இருக்குன்னா டைரக்டா InstaSolveல போய் லைக் மேபி நைட் தான் மோஸ்ட் ஆஃப் த ஸ்டூடெண்ட்ஸும் நைட் தான் என்ன ஸ்டடி பண்ணும். ஸோ அதுக்காக உங்களுக்கு ஏதாச்சும் அப்போ ஒரு டவுட் இருக்குன்னா ஆக்சுவலி இன்ஸ்டா சால்வ் இருக்கு. ஸோ இன்ஸ்டா சால்வ்ல போய் அங்க ப்ராப்பரா கொடுத்தா ஓகே, ஏதாச்சும் ஸ்கிரீன்ஷாட் ஓகே, இல்லைன்னா ஏதாச்சும் போட்டோ எடுத்து அதுல போட்டா அப்போ ஆக்சுவலி இன்ஸ்டா சால்வ் ஆக்சுவலி வேத் ஓகே, வேத் எப்படி வேதோட ஸ்பெஷாலிட்டி என்னன்னா it will give. So நீங்க ஏதாச்சும் போட்டோ போட்டா it's actually completely NCERT based AI தான். Okay, it is completely NCERT based AI தான். So அது ப்ராப்பரா என்ன ப்ராப்பர் அதோட ஆன்சர் உங்களுக்கு கிடைக்கும். Okay, எந்த கொஸ்டின் வேணாம். So here you can see full length mock test இருக்கு. Okay, so here we are giving 40 full length mock test உங்களுக்கு attend பண்ணலாம் இங்க இருந்து. So here you can see இது live and upcoming and miss பண்ணது and attempt பண்ணது. Okay, so here you can see. So yes, இது almost 2000 students இது ஃப்ரீயா கிடைக்கிறதுல access பண்றாங்க. So நீங்க இதுவரைக்கும் access பண்ணலனா இது உங்களோட mistake. Okay, so because இது ஃப்ரீயா கிடைக்குது. So actually இது actually 4999 ஒரு கிராஷ் கோர்ஸ் தான். பட் உங்களுக்கு இப்போ இந்த சிச்சுவேஷன்ல ரீநீட் வந்ததுனால we are giving it as free. Okay, so இப்பவே ஜாயின் பண்ணிக்கோங்க. Okay, come on. So find the number of hyperconjugation. So tell me guys, what is hyperconjugation number? Hyperconjugation structure. Yes, cute. Like the like button smash பண்ணுங்க guys. Yes, nice. Yeah, so here you can see, come on, I can access live. ஏன்னா லைப்ரரி எல்லாருக்கும் அக்சஸ் பண்ண முடியும் தானியா. So இப்போ நான் ஷோ பண்ணி இருக்குல்ல, so அது மாதிரி you can see library there. So library access பண்ணலாம். Okay, settle it. Try. Just try now, Dania. 3, 5, 6 here I can see answers. Done like the session. Okay, so here, so this is a double bonded carbon. Okay, this is a double bonded carbon. This is also double bonded carbon. So this double bonded carbon is directly attached with this carbon. So this carbon is actually alpha carbon. So this alpha carbon contain 3 hydrogens. So HCS is actually 3 here. Okay, when you consider this one, so this is also double bonded carbon, this is also double bonded carbon. This double bonded carbon is connected with this hydrogen. So and this double bonded carbon is connected with this hydrogen. So this carbon, okay, this carbon contain 2 hydrogen. 4, 5, 3. Yes, 5. So hyperconjugated structure is actually 5. So here you can see, yes, this is a double bonded carbon. So this is a double bonded carbon, and this double bonded carbon is directly connected with 2 other carbon. So this carbon contains 3 hydrogen and this carbon also contains 3 hydrogen. So total hyperconjugated structure is actually 6 here. I hope it's clear. I will check again, ma'am. Okay, just check. இல்லடா மொபைல்லையும் லைப்ரரி அக்சஸ் பண்ணலாம், பார்க்க முடியும். Next is free radical. Okay, you can write only 2 molecules out of the hyperconjugated structure. Tell me, how many hyperconjugated structures are there? Ada? Okay, so here you can see this is a carbo, that is a free radical. So this is a alpha carbon 1, 2, 3. Here also 1, 2, 3. Hyperconjugated structure is 3. Here also this is the alpha. This is a free radical. This is the alpha carbon. This alpha carbon contain 2 hyperconjugated structure. So guys, so my next question is which molecule is more stable? So okay, idoda application I will tell you. Stability of carbocation, stability of carbon free radical, and stability of carbanion. Okay, so stability of carbanion, and to compare bond length. Not carbanion. This is wrong. Stability of alkene. Carbanion is not possible. So stability of alkene. Okay, stability of alkene. So stability of carbocation, free radical. So we will use same rules. Okay, and stability of alkene, and to compare bond length. Okay, so here compare the stability. So this is molecule, molecule 1, 2, 3. Okay, so here you can see 3 compounds. Which compound is more stable? Tell me quickly in the chat box what. What? Neve. So tell me quickly, which molecule is more stable? 1, 2, 3. Here you can see 3 compounds. Which compound is more stable? Which molecule is more stable? Here you can see 3 carbocations. Which carbocation is more stable? 1, then 2, then 3. Okay. So how we will check here? So we can check. So this is a carbocation. Okay. So this carbocation contains total hyperconjugated structure is actually 9. When you consider this one, hyperconjugated structure is actually 6. This hyperconjugated structure is actually 3. Okay. So 1 is more stable, then 2, then 3. Why? Because if hyperconjugated structure increases, stability also increases. Okay. Hyperconjugated, number of hyperconjugated structure increases, stability also increases. I hope it's clear. Clear aleda? Clear alle? So here also you can see. So tell me which one is more stable? Which carbon free radical is more stable? Which carbon free radical is more stable? Which carbon free radical is more stable? Here you can see. Come on, speed up. Neve, Vasanta, Ganesha, Joshua, Tanya, Jahi 1, 2, 3. Shweta. Joshua saying 2. Only 2. I'm right. I said write the order. Write the stability order. 4, 2, 1, 3. Okay. 2, 4, 1, 3. I can see lots of orders. Then I will check. Okay. Then I will check. Here 1, 2, 1, 2, 3. So hyperconjugated structure is actually 5. Here hyperconjugated structure is actually here 1, 2, 3. 1, 2. Here it is 1, 2, 3. 3, 3, 6, 7, 8. 8. When you consider hyperconjugated structure, here it is 1. 1. Here hyperconjugated structure is 9. So what is the correct answer? 1 to 4 is more. Then 2, then 1, then 1, 2, 3. Yeah, this is the order. 4, then 2, then 1, then 2, then 1, then 3. 4, 2, 1, 3. Yes. Clear alle? I hope it's clear. Clear alle? Ada, mistake irundiruchina, it's okay. It's okay da. Why you guys are deleting? Why you guys are deleting the answer? Okay. So next is resonance effect. Okay, resonance effect. What is resonance effect? So book kamikka ada library books ippada show pannadilla. You can see here. You can see here. காமிக்கும்டா அங்க இருக்குடா ஃபர்ஸ்ட் புக் இருக்கு let me check a content library. You can see content library. Okay, try option me. You can see the link. Okay, you can see the link. below the session. Okay, description box. You can see the link. So just download. I mean, not just register for that free crash course. Then you will get. Okay, try again. Try again. Then I will check. Okay. Then I will inform our technical team. Okay. Okay, next resonance. So resonance is, I told you now. So when you consider hyperconjugation, inductive effect, resonance effect. So most important effect, electron displacement effect is actually resonance effect. Okay. So when you consider resonance effect, okay, resonance effect la namakku theriyunda. So resonance effect la when you consider benzene ring, okay, benzene ring la actually two structures irukku. Okay, when idum benzene ring da. இதுவும் பென்சீன் ரிங் தான். ஓகே, சோ ரெண்டுமே பென்சீன் ரிங் தான். இல்லாம நமக்கு இது மட்டும் தான் பென்சீன் ரிங் இல்லனா இது மட்டும் தான் பென்சீன் ரிங்னு சொல்ல முடியாது. ஓகே, இந்த மாதிரி ஸ்ட்ரக்சர். ஓகே, that means for some molecule we can't explain all the property using one single structure. Okay, for that molecule we will maybe use two or more structures. So that type of molecule or that type of compound we will say that is resonance molecule. Okay, resonance molecule. Okay, so different structure show pandrena, that is actually resonance structure. Okay, so when you consider resonating structure are hypothetical. When you consider benzene true structure irukla, so that is actually imaginary or hypothetical structures. Okay, so but it should follow Lewis structure. Okay, but it should follow Lewis structure na enada. So for example, carbon ku namakku theriyum 4 bond da irukum. Okay, so this is hypothetical, imaginary. So we can give 5 or 6 or 7 or something in a bond. Illana electrons kodukka mudiyuma illa. So you should follow Lewis structure. Okay, if you are drawing the resonance structure also, you should follow Lewis structure. Okay, same break. Okay. Okay, so next the resonance hybrid is actually, it is the actual structure. Okay, when you consider resonance hybrid, so resonance hybrid the actual structure. Reason enna, resonance hybrid or energy is very less. Energy is very less means the stability is more. Okay, so stability is more. So for resonance hybrid, I will tell you. Okay, how to draw resonance hybrid and I will tell you. Okay, so when you consider CO2, so when you consider CO2 la, how we will draw resonance structure? Yes, resonance structure draw பண்ணும்போது இந்த double headed arrow தான் யூஸ் பண்ணணும். Okay, so here உங்களுக்கு carbon பார்க்க முடியும், ரெண்டு oxygen இருக்கு. So carbon மேல only one carbon is there, so positive இருக்கு. So here இங்க தான் double bond இருந்தது, so இங்க double bond ஆயிட்ட, இங்க minus வந்துட்ட. So this is the structure. So ரெண்டுமே same structure தான். Okay, ரெண்டுமே same structure தான். But idile enna irukada, this is actually resonance structure. We can't explain in one. We can't explain the property using one structure. So adanale we are using more structures. Okay, andha madri structures da resonance structures. So when you consider resonance structures, so yeah, we should draw the resonance hybrid alle. So yes, this is oxygen. So here you can see இங்கேயும் என்ன double bond வருது, இந்த oxygenலும் double bond வருது. So I am drawing just partial double bond. Okay, I am representing actually partial double bond. So இந்த carbonல positive இருக்கு, so இந்த carbonல இங்கேயும் negative இருக்கு. So I am giving negative. Okay, I am giving negative. So இங்கேயும் negative கொடுக்க முடியுமா? That is not possible. Actually we have only one negative தான் இருக்கு. So அந்த one negative share பண்ணணும் இப்போ. So இங்க பார்த்தா உங்களுக்கு தெரியும், ரெண்டு மாலிக்யூல்லையுமே actually one negative charge தான் இருக்கு, but two oxygenum இருக்கு. So one negative charge is sharing two oxygen. So that means it is 1/2. So this is the resonance hybrid. This is actually resonance hybrid. I hope it's clear allada. ஏதாச்சும் doubt இருக்கா? More structure has more stability. Very good. More resonating structure, more stability. Correct. So then I will draw second molecule, that is CO2 2-. So carbon is there, double bond O. This is O and this is C double bond O. This is C single bond O minus. This is double bond O. This is single bond O minus. And next structure is actually C double bond O, single bond O minus, here also O minus. Okay, this is the resonating structure. Okay, this is the resonating structure. So what we can do, so we should draw the resonance hydrogen. How to find a compound have and it's very simple, that I will tell you. Okay, I will tell you how to draw the resonating structure. Okay, now I'm just resonating resonance energy, that I will tell you. Resonance energy ellame I will tell you. Okay, so this just enna inga carbon 3 carbon irukku, 3 oxygen irukku. So in the 2 oxygen la negative irukku. Okay, 2 oxygen la negative irukku. So and the double bond na just change pandren. Okay, so idu mattum illama namakku enna again enna different type la resonance structure draw panna mudiyum, that I will tell you eppadi resonance structure draw pannanum. Okay, that I will explain. Okay, so how to draw resonance hybrid. Okay, so carbon and 3 oxygen is there. So எல்லாத்துலயும் partial double bond. Okay, எல்லாத்துலயும் double bond இருக்குல்ல, partial double bond. So we know that here CO2 contain, okay, CO2 contain not CO3 contain 2 minus. Okay, CO3 2 minus. Okay, so that means CO3 contain 2 minus charge. Okay, so 2 minus charge eppadi this equally distribute panna mudiyum. So namakku theriyum 2 minus charge da irukku. Okay, 2 minus charge da irukku, but we know that 3 oxygen atom is there. Okay, 2 by 3. So 2 minus 2 divided by 3. Okay, 3 oxygen atoms are there. So this is the resonance hybrid. Okay, this is the resonance hybrid. I hope it's clear, allada. I hope it's clear. So when you consider resonance actually Suki Abhimanyu கேட்டது. Okay, resonance consider பண்ணும்போது அதுக்கு என்ன கொஞ்சம் conditions இருக்கு. Okay, mainly 2 conditions தான் இருக்கு. First condition is all participating elements should be in one plane. Okay, one plane. So that is first condition. And second condition, it should have conjugation. Okay, it should have conjugation. So that what is actually conjugation? Now explain. Yes, I will explain. Okay, so yes, it should have conjugation. Now what is conjugation? So that I will tell you what is conjugation. So lone pair single double. Okay, so lone pair single double in the madri structure. Okay, in the madri bonding vanda you can see conjugation. And positive single double vanda, negative single double vanda, and free radical single double vanda you can see conjugation. And also you can see conjugation in alternate double bond. Okay, alternate double bond iliyum conjugation irukku. And next is back bonding. Okay, this is back bonding. What is back bonding ada? So here you can see A. Okay, A contain vacant orbital, and B la enna irukku lone pair irukku. Okay, so this B is giving this lone pair to vacant orbital of A. So you can see back bonding in AB. Okay, here you can see back bonding in AB. I hope it's clear, allada. Clear or not? Clear, ma'am? Understood? Okay. So conjugation means here you can see lone pair single double bond irunda we can say yes, conjugation is there. Okay, or positive single double. I will give you one example also. Okay, Ganesha, I will give you one example also. Okay, no worries. So negative single double and free radical single double, alternate single double, and back bonding. So I will give you an example, then it will become so clear. Okay, so idiliyum konjam like back bonding alla. So here you can see this molecule. In the molecule la resonance irukka illaya? Resonance irukka illaya? First 3 molecules irukku. So idile ella molecule ku resonance irukka illa edachu molecule ku resonance illaya? Come on. Do you remember that rules? So எல்லா plane, எல்லா atoms, எல்லா elements single plane ல இருக்கணும். So only one plane ல இருக்கணும். And next என்ன, it should have conjugation. So check conjugation. Okay. Resonance is present. Yes, resonance will be there. Okay. Resonance. Okay, Jahi. Suki. And I will tell you. So here you can see minus single double. Minus single double. Here you can see. Just a second. So here you can see minus single double. Conjugation is there. Okay. Minus single double. Okay. Minus single double bond. Resonance is there. Okay. So inga resonance irukkiradhukku reason enna? Inga enna conjugation irukku? What type of conjugation you can see here? What type of conjugation? Come on. Inga enna conjugation irukkada? Minus single double, plus single double, lone pair single double. Come on. Double, single, double. Yes, very good, Joshua. Single, double. Alternate, double. Okay, single, double is not possible. Okay, here you can see double, single, double. Okay, alternate, double bond is there. Okay, alternate, double bond is there. Okay, alternate, double bond is there. So you can write it as double, single, double. Okay, so or we can say alternate, double bond. Okay, so when you consider this molecule, positive, single, double conjugation is there. Okay, positive, single, double conjugation is there. Okay, I hope it's clear. X double Y single. Okay, I can see. Okay, double, single. So we can't say double, single. Okay, alternate, double. Okay, alternate, double. So double, single, double, or you can write alternate, double bond. And here it is positive, single, double. Okay, here it is positive, single, double. I hope it's clear, Aleda. Any doubt? Any doubt? So we can start drawing. Okay, then we can start. So resonance structure. So inga minus single double resonance structure eppadi varayalam. So I will show you. So this negative will become bond pair, and this double bond will become negative. Okay, negative charge. So I will draw double bond, and here it will become negative. Okay, so this is the resonance structure of this molecule. Okay, in the molecule or resonance structure in the molecule. So then we can draw second molecule. Okay, so inge enna nadakudhu? So here you can see alternate double bond irukku. So alternate double bond varumbodhu edachu one double bond complete break out. Okay, so one illa rendu double bond complete break out. So inga we know that oxygen is more electronegative element. Okay, oxygen is more electronegative element. So adanal in the double bond break aayi oxygen kuda non pair ah maarum. Okay, so and this double bond will break, and here it will also form bond pair. Okay, it will also form bond pair. So here 1 2 3, here you can see double bond O minus. Okay, correct for that. Yes, this is the resonating structure. Then next one, when you consider this one, so this double bond will break, and here it will form bond pair. Okay, this double bond will break and it will form bond pair, and here it will form positive charge. So I am going to draw this molecule 1 2 3. I hope it's clear. Any doubt? Ganesha க்கு தான் டவுட்டா இருந்ததுன்னு நினைக்கிறேன். கணேஷா ஏதாச்சும் டவுட் இருக்கா? கணேஷா ஏதாச்சும் டவுட் இருக்கா? So everyone quickly smash the like button. Everyone quickly smash the like button. Now it's clear. Thank you so much, ma'am. Okay. No doubt. Okay. So I hope it's clear. Then draw the resonance structure. Try to draw the resonance structure. So I will give you a 5 minutes break. Okay, I will give you a 5 minutes break. So what is time now? Okay. So I will give you 5 minutes break. 5 minutes break. Live target இருக்கு. Okay. Ma'am, you are from which branch? எந்த branch? புரியல. Okay. Nadu guys. So yes. So yes guys. Guys, break முடிஞ்சாச்சு. Panni Maharaj branch location. What branch? What location? Branch location. Okay. So we can start anyway. We can start. I am head out. How to study chemistry reaction from bio. It is possible now. It is possible. Sometimes it is possible. I mentioned it's reaction. Okay. So in biology book also there are some reactions. Chemical reactions are there in biology book. Oh, it is there. It is there. Joshua. Roasting. Okay. So come on guys, draw the resonating structure. Okay. So here you can see what is the conjugation. So what type of conjugation you can see here? What type of conjugation you can see here, Ada? What type of conjugation you can see here? Yes, I'm good. I'm good, Grishma. How are you? Lone pair, double bond. Okay. Lone pair, double bond. Very good. Yes. So we know that oxygen contained lone pair. Okay. So then what will happen? Lone pair, single, double. Okay. Lone pair, single, double. So then what will happen? So what will happen? Yeah, it's very simple. This lone pair will come this side and here it will form bond pair. That means double bond, and this double bond will break and it will form negative charge. Okay. It will form negative charge. So free radical single bond. Clear, Joshua? But in class 12 book, oh, clearly. It is there, Ada. It is there. You don't know. Lone pair and double bond. Lone pair and double bond. Correct, correct. Lone pair, single, double bond. Okay. Lone pair, single, double. So what is next? What is next? What is next? Here it will form negative charge, double bond, carbon, oxygen, hydrogen, and here you can see. So this negative charge in second. Okay, so this is the resonating structure. Again here you can see conjugation. Okay, again here you can see conjugation. Negative, single, double. So this negative will become double bond and this double bond will become negative charge. So same. Okay. So this negative will become double bond. So this will become double bond and this double bond will become negative charge. So here you can see next. What is next? Okay. Here you can see this negative charge will become double bond and this double bond will become negative charge. So negative charge. And here, and in next step, here you can see this negative charge will become double bond and this double bond will become lone pair. And this lone pair will become. This is the resonating structure. Here you can see 5 resonating structures. Okay, here you can see 5 resonating structures. Okay, it's okay, it's okay. Jahi clear hai? So here you can see 5 resonating structures. So here you can see another question. You can do it as homework. Okay, just do it as homework. Okay, so when you consider stability of resonance structure or stability, so there are some rules for stability. Okay, so the first rule is, so when you consider neutral or charged molecule, okay, when you consider neutral or charged structure, neutral structure stability is more. Okay, when you consider stability of neutral structure, it is more than charged structure. Okay, then second rule, stability is directly proportional to number of pi bonds. Okay, if pi bond increases, stability will also increases. Next is stability is directly proportional to negative charge on stable atom. Okay, so we know that when you consider carbon and oxygen, so which is more stable, C minus or O minus? Which is more stable, C minus or O minus? Which is more stable? Which is more stable, C minus or O minus? Which is more stable? Come on, guys. O minus or C minus? O minus or C minus? Okay, Mukund, your name is not Mukund, I know. O minus, yes, O minus, because it's more electronegative. So O minus is more stable, okay, not C minus. So when you consider, say, like minus charge on electronegative atom means it's stable, okay. So same way, so O plus and C plus, which one is more stable? O plus or C plus, which one is more stable? You know that oxygen is more electronegative. Oxygen contain plus means positive means it is less stable, okay. So here C plus is more stable. Okay, C plus is more stable. Yes. So stability is directly proportional to positive charge stable on atom. And charge separating resonating structure are less stable. What is charge separating resonance structure? When you consider positive and negative. Positive and negative, okay, so adjacent carbon, if adjacent carbon contain opposite charge means it's more stable. So if positive and negative atom has like distance, okay, if the distance is high means that is less stable. Okay, distance is high means it is less stable. Opposite charge order distance high means it is less stable. Opposite charge order distance less means it is more stable. And like charge on adjacent atom are less stable. So when you consider negative, positive, negative, and negative and lone pair, it is actually less stable. Okay, it is actually less stable. Here you can see. Then I will give you some question. Okay, I will give you one question. You can do other questions. Okay. So which is least stable resonating structure? Which is least stable resonating structure? Which is least stable resonating structure? Yes, D. Yes, can you tell me the reason? So we can check. Okay, we can check from first rule. What is first rule? Charge atom contain less stable. Okay, charge atom is actually less stable. Here you can see positive, negative, positive, negative. Yeah, positive, negative is there. So every molecule contain charge. So we can't say which one is more stable, less stable. We can't say that. Okay. So next, what is second rule? What is second rule? So second rule means number of pi electron is more, stability is more. So how many pi electrons are there? 2 pi electrons. And here also 2 pi electrons. Here it is 1 pi and here it is 1 pi. So this is not the answer. A and B we can eliminate. Okay. So C and D is there. So we can check next rule. So yes, here you can see positive and negative. Yes, opposite charge in the adjacent atom. Obviously, it is more stable. And here carbon contain positive charge, carbon contain positive charge. Here carbon contain positive charge, carbon contain positive charge. Okay, then what is the twist here? Yes, after the session, Gobia will take class. Yes. So we know that oxygen contain lone pair. Okay, da? Oxygen contain lone pair. So oxygen contain lone pair means here you can see lone pair and negative. Okay, so the electron density is more. Okay, lone pair and electron density is more. So it is D is less stable. Yeah. Then what? Then next is extended conjugation and cross conjugation. What is extended conjugation? Here you can see back-to-back conjugation. Okay, here you can see back-to-back conjugation. That is actually extended conjugation. What is cross conjugation? So you can see different conjugation. Okay, one conjugation here and another conjugation here. This is cross conjugation. When you consider cross conjugation, the stability of cross conjugation and extended conjugation, the stability of extended conjugation is more. Okay. The stability of extended conjugation is, so I am writing extended conjugation stability is more than conjugation. Cross conjugation. Okay. I hope it's clear, Ale. I hope it's clear. Then we are moving to next resonance effect or mesomeric effect. That I just okay. So here you can see resonance effect. Okay. So double bond is connected with a group. Okay. So a group of atom or group. So if this group contain lone pair of electron means, okay, if this group contain lone pair of electron, we can say that it is plus M group. Okay. If this group contain lone pair of electron and double bond atom. Okay. So double bond, if this group contain double bond, we can say that it is actually minus I group, minus M group. Okay. So when you consider this group, okay, yes, here we know that nitrogen contain lone pair. So it is actually plus M group. So here you can see CH double bond O. Okay. So this carbon is directly double bond connected with oxygen in double bond. Okay, so that carbon is connected with oxygen in double bond. So here you can see this group is actually minus M group. Okay, this group is actually minus M group. When you consider resonance effect or mesomeric effect, so it will operate to pi bond. Okay, it will operate only in pi bond, and it is a permanent effect, and actual charge development you can see, and distance independent. Okay, it is actually distance independent. So here you can see plus M and minus M group. So when you consider plus M group will enna irukku lone pair of electrons are there. When you consider minus M group will enna irukkuda double bond is there. Okay, double bond is there. Then we are moving to compare the stability. So you can write, okay, you can do some questions, compare the stability questions. Okay. Compare the stability, first and second one. Yes. When you consider this molecule, so yeah, we have cross conjugation. Okay, here we have cross conjugation. So cross conjugation means it is more stable. Here you can see only one conjugation. And you asked some question, I forget. Okay, so here also you can see cross conjugation, it is more stable. Okay, yes. Then we are moving to next topic, that is aromaticity. So when you consider aromaticity, it should follow some condition. Okay. So the first condition is cyclic, second one is conjugation, third one is planar, and fourth one is Huckel's rule. Okay. So what does cyclic means? Cyclic means obviously it should be a closed structure. Okay. It should be a closed structure. What is conjugation? We already discussed the conjugations. Okay. We already discussed the conjugation. So conjugation means like maybe positive single double or alternate double, single double double, not positive single double, negative single double, lone pair single double, and free radical single double, or alternate bonds, alternate double bonds, or you can see one more bond, back bond. Okay, so or you can see back bond. So adi irundha mattumda we can say that conjugation is there. Okay, and next is planar. Okay, every atom should be in one plane. Okay, every atom should be in one plane. And next is Huckel's rule. Okay, in the three rules பிரச்சனை வந்தா, okay, so ஏதாச்சும் condition fail ஆயிடுச்சுனா, okay, so any of the three condition fail ஆயிடுச்சுனா, we can say that it is non-aromatic. Okay, we can say that. So I'll write non-aromatic. Okay, ஏதாச்சும் point, okay, ஏதாச்சும் condition fail ஆயிடுச்சுனா, we can say that is non-aromatic. So what is Huckel's rule? Okay, first we can discuss about Huckel's rule. What is Huckel's rule? 4n plus 2 pi electron. Okay, 4n plus 2 pi electron. 4n plus 2 pi electron. Okay, 4n plus 2 pi electron. So when you consider 4n plus 2 pi electron, what is n? So n will start from 0. So if n is equal to 0 means, this term 2 pi electron. If n is equal to 1 means 4 plus 6 pi electron. If n is equal to 2 means 10 pi electrons. If n is equal to 3 means 3 into 4, 12, 14 pi electron. Okay. So this is actually Huckel's rule. Okay. So if the molecule should contain 2 electron or 2 pi electron or 6 pi electron or 10 pi electron or 14 pi electron means yes, that molecule is actually aromatic molecule. Okay, that molecule is actually aromatic molecule. So this is aromatic molecule or a condition. Okay, so here I will write aromatic molecule. Okay, aromatic molecule. Okay, this is very important. Aromatic molecule. This is non-aromatic molecule. And there is one more molecule, anti-aromatic molecule. Okay, so what is the rule for anti-aromatic molecule? Anti-aromatic molecule or a rule and so that I will tell you. That is yes, that is 4n pi electrons. Okay, 4n pi electrons. Okay, 4n pi electrons. So if n is equal to 1, so it is 4 pi electron. And if n is equal to 2, that is 8 pi electrons. N is equal to 3, that is 8, 12 pi electron. If n is equal to 4, 16 pi electron. So this is actually anti-aromatic molecule. Okay, anti-aromatic molecule. This is also very important. Okay, so first non-aromatic irukku, anti-aromatic irukku, and aromatic irukku. So this is very important. Okay, and when you consider the stability of anti-aromatic, non-aromatic and aromatic molecule or stability சொல்லும்போது more stable molecule is actually aromatic molecule. Aromatic molecule. Aromatic molecule. Then non-aromatic molecule. Non-aromatic molecule. Then anti-aromatic molecule. So that is actually stability order, okay? Stability. So stability less, so anti-aromatic, non-aromatic, aromatic, non-aromatic and anti-aromatic, the stability order. Okay, so this is very important. So I will show you some molecules. So adile neenga aromatica, anti-aromatica, non-aromatica nu neenga sollanum. Okay, so indha madri questions we can expect. Okay, GOC la irundhu illana like 11th chemistry la irundhu indha madri basic question we can expect. Okay, 4n pi electron. Okay, not 4n electron, 4n pi electron. Okay, so come on guys. Aromatic. You are saying Suki Abhimanyu is saying it's aromatic. Kirtana, Jahi, aromatic. So can you tell me the reason also? So we should check all the points. So first point is cyclic. Yes, it is cyclic. First point is actually cyclic. Yes, guys, it is cyclic. And what is second point? Second point is planar. Yes. So guys, here you can see every carbon is actually sp2 carbon. Okay, every carbon is actually sp2 carbon, means obviously it is planar. Okay, Yella carbon sp2 la irundha, we can say it is planar molecule. Okay, then third point. What is third point? Conjugation. Yes, conjugation is also there for every atom. Okay, for every atom conjugation should be present. Okay, when you consider this, because alternate double bond is there, conjugation is also there. Yes, then we can check Huckel's rule. Okay, so what is Huckel's rule? 4n plus 2 pi electrons. So here how many pi electrons are there? 1 2 3 4 5 6 6 pi electrons are there. Okay, 6 pi electrons are there. Yes, 6 pi electrons are there. Yes, here you can see 6 pi electrons are there. Yes, 6 pi electron means it is aromatic only. Okay, 6 pi electron means it is aromatic only. Yes, guys, it is aromatic only. Yes, correct. This molecule is actually aromatic molecule. Okay, I hope it's clear, Aleda. Then I will give you another molecule. Come on. Is it aromatic or anti-aromatic? %100% sure it is aromatic. Joshua? Charge is considered as pi bond. Nice. So nice, Kirtana. So come on, is it aromatic or non-aromatic or anti-aromatic molecule? Anti-aromatic. Okay, you're saying it's anti-aromatic. Okay, we can check. Anyway, we can check. So first one, what is our first point? cyclic. And yes, we know that it is closed structure, it is cyclic. Then next one is conjugation. Conjugation for every atom. So positive single double, positive single double, positive single double. Yes, conjugation is there, conjugation is also there. Then we should check planar. Planar means I already mentioned that it should be sp3. Okay, ellame sp3 carbon irukkanum. So when you check here, okay, so inga yes, இது double bond தான். இது actually ரெண்டுமே sp3. But என்ன இங்க ஒரு நெகட்டிவ் இருக்கு, அது sp3 ஆ இல்லையா, அதுதான் டவுட். Okay, so here we know that. So when you consider negative charge, okay, double bond இருக்கு, negative charge இருக்கு. So இப்படி நெகட்டிவ் வரும்போது, okay, நெகட்டிவ் வரும்போது என்னடா, இந்த நெகட்டிவ் actually இந்த நெகட்டிவ் என்னடா இங்க வரும். ஓகே, அது ஸ்டேபிளா அங்க இருக்காது. ஓகே, சோ இந்த நெகட்டிவ் என்ன, இதோட ரெசோனன்ஸ் ஸ்ட்ரக்சர் ட்ரா பண்ணும்போது this negative will become bond pair and this bond pair will become negative. ஓகே, இது சேஞ்ச் பண்ணிட்டே இருக்கும். ஓகே, so we can't consider that negative. ஓகே, அந்த நெகட்டிவ கன்சிடர் பண்ண முடியாது. So here we can see 3 sigma bond is there. Okay, 3 sigma bond is there. So 3 sigma bond means here we can consider yes, it is planar. Okay, sp3 consider panna mudiyum, it is planar. And fourth one, what is fourth one? Huckel's rule alla, Huckel's rule. What is Huckel's rule ada? 4n plus pi electron. So how many pi electrons are there? 1 2 pi electron, and we will consider this lone pair also. So 4 pi electrons are there. So 4 pi electrons means, so 4 pi electrons means ten pi electron. How? It will become anti-aromatic. Okay, I hope it's clear. Then I will give you another molecule. So here you can do this one. Here I just want to add one more point. So when you consider carbocation, so carbocation எப்பவுமே என்ன sp2 hybridized. Okay, so it's a single carbocation. Okay, single carbocation. So here you can see double bond, single carbocation, that is also sp2. And when you consider carbanion, so carbanion consider பண்ணும்போது that is also sp3 இருக்கும். Okay, this is single carbanion consider பண்ணும்போது அது sp3 இருக்கும். But double bond single and இங்க lone pair இல்லனா இங்க என்ன negative charge வந்தா we can consider it as a sp3, not sp3, sp2. Okay, sp2 ஆ consider பண்ண முடியும். Okay, so it is planar. Okay, so here guys like lots of examples are there, so you can do it. Okay, you can do it your one. Okay, so here you can see application of aromaticity to compare dipole moment. So when you consider dipole moment is directly proportional to stability of carbocation. Okay, stability of carbocation. So here we can make carbocations alla. So in the bond break ஆகும்போது oxygen positive and carbon, not oxygen positive, oxygen negative, and here carbocation will form. Here also carbocation will form positive. Here also carbocation will form positive. Carbocation will form positive. This is carbocation positive. This is negative. Okay. Inge negative. Inge positive. Carbocation will form. Okay. Okay. Here also. Okay. I hope it's clear. So just check aromatic, anti-aromatic, and non-aromatic. Idla aromatic molecule is actually more stable, then non-aromatic, then anti-aromatic. Okay, so இதுதான் rule. Okay, இதுதான் rule. ஏதாச்சும் doubt இருக்காடா? ஏதாச்சும் doubt இருக்கா? When you consider stability of, yes, this is the application of aromaticity or the stability of acidic strength. So we know that stability of acidic strength or acidic strength is directly proportional to stability of carbanion. Okay, so in the H plus form agum, this will minus H plus minus H plus minus form agum. So in you same partha podo, we know that aromatic is more stable than non-aromatic, then anti-aromatic. So when you consider carbocation, guys, this is very important, okay? When you consider the stability of carbocation, so namakku theriyum non-aromatic. Suki means correct. Oh, really? So
battery is full. Remove the charger.
So yeah, guys. So here, she yeah. Wow. Wow. You will definitely become a poet, no doubt. Okay. Sit. Okay. Nagarajunava. Adennada? Nagarajunava. What is that? Nada. So okay. So first one is back bonding. Okay, what is back bonding? So I already told. When you consider it's carbocation. Carbocation means obviously it's contained vacant orbital. So when it's connected with a group A, so that A contain lone pair of electron. If that A contain lone pair of electron, so this A is ready to give that lone pair to that vacant orbital. Okay, vacant orbital you can see double bond in the form of. So this is actually back bonding. இல்லடா கோபிகா மேமோட கிளாஸ் ஆக்சுவலி 6க்கு இல்ல 7க்கு தான். ஓகே 6க்கு இல்ல கோபிகா மேமோட கிளாஸ் 7க்கு தான் இருக்கு. ஓகே okay. So yes, back bonding. So here you can see back bonding. Okay, so when you consider stability of carbocation, back bonding structure is more stable. Okay, so அவங்க ஏதாச்சும் ஒரு ஸ்ட்ரக்சர் உங்களுக்கு கொடுத்துட்டு which structure is more stable னு கேட்டா நீங்க first back bonding தான் செக் பண்ணணும். அதுக்கப்புறம் aromaticity, then Isomeric effect or resonance effect, after that hyperconjugation, then inductive effect, last the inductive effect check பண்ணனும். Okay, clear? Last inductive effect. And when you consider stability of carbocation is directly proportional to plus M plus H and plus I, and inversely proportional to minus M minus H and minus I. Okay, I hope it's clear. Then next one, hybridization. I already discussed. We know that electronegativity is directly proportional to percentage S character. Okay, so S character nu sollumbodhu namakku theriyum sp, sp2, sp3 is there. So here என்ன single bond, அதுக்கப்புறம் double, அதுக்கப்புறம் triple bond அப்படிதான் என்ன S character ஓட basisல electronegativity. So we know that electronegativity is inversely proportional to stability of carbocation. Okay, so electronegativity element positive charge means it is unstable. Okay, yes. Then I will give you question. Okay, just do it. Okay, identify the stability order. Come on guys, we can do some question. Come on guys. Welcome Kirtana, welcome everyone. What is this? Bio class 7க்கு தான் இருக்குடா. So come on fast. Yes, Gautam. So tell me what is 3, 2, 1. Okay, let me check. So we know that first, when you consider carbocation, okay. So carbocation means, yes, how many hydrogen is there? Hyperconjugated structure is actually 2. Okay, here it is 2. So first we should check back bonding. There is no back bonding here. Then you should check resonance. There is no resonance here. Then you should check no, back bonding. So after back bonding, you should check aromaticity. Okay, there is no aromatic molecule. Then resonance, no resonance. Then what? After resonance, you should check hyperconjugation. Yes, hyperconjugation is there. So we can write hyperconjugation. Okay, 1, 2, 3 and 1, 2. So hyperconjugated structure is actually 5. So here hyperconjugated structure is actually 6. So 3, 2, 1. It is the stability order. Here I can see 1, 2, 3. This is the order. So yes, here you can see 1, 2. Here hyperconjugated structure is actually 2. Here the hyperconjugated structure is actually 3. And here it is 1. Hyperconjugated structure is actually 3, 3 plus 1, 4. And hyperconjugated structure is actually here 1 and here 1. Here it is, no. Here it is 3. And here it is 3. And here it is 1. 3, 3, 6, 1, 7. So here also 3, 2, 1. Here also 3, 2, 1. Right? Yeah, correct. So this is also 3, 2, 1. This is also 3, 2, 1. Then I will give you another molecule. Yeah, this one. Come on, guys. Which molecule is more stable? 3, 4. So which molecule is more stable? Both are 3, 2, 1. Yes, correct. Suki Abhimanyam. இல்லடா, there is no confusion. They're ரொம்ப simple. ரொம்ப simple. நம்மள தூக்கி போடுறாங்க. I'm a little confused. Sorry, ma'am. Okay. It's no issue. I hope it's clear. Now clear, alle? Tell me duration of class. I will finish class around 6 o'clock. I will finish class around 6 o'clock. 2, 1, 1, 2. Here I can see 1, 2, 1, 2. Okay, let me check. So here you can see positive. Yeah, I already told you. Yeah, lone pair. This one is more stable because we know that oxygen contain lone pair. It is and oxygen here. What? Here it is positive, so it is more stable. Okay, it is more stable. Why? Because like lone pair means we know that it contains back bonding. Okay, back bonding is there. It is positive. Back bonding is there. So back bonding structure. So it is more stable. Then you consider this one. Which one is more stable? CF3 or CLF3? Which one is more stable? Come on, quick. Which one is more stable? Jahid Singh. Second one, fourth one. 2 is more stable. 21 seconds. Okay, guys, when you consider this one is more stable. Why? Because when you consider carbon and fluorine, the size of carbon and fluorine is almost similar. So when you consider the size of carbon and fluorine, the size is more. Okay, so here CF3 is more stable because of the size. So we know that it contains lone pair. Okay, carbocation. It also contains lone pair carbocation. Obviously, back bonding is there. Here also you can see back bonding structure. Here also you can see back bonding structure. But the thing is, like when you consider this chlorine and carbon, the size is actually almost similar. Okay, but when you consider chlorine and chlorine and carbon, the size is actually the difference actually, it is huge, okay? So when you consider fluorine and carbon, size is almost similar. Then I will give you another question. Come on. Because of back bonding. Yes, yes, yes. Here. Tell me the correct answer. Tell me the stability order. Yes, definitely back bonding தான் consider பண்ணணும். இங்கேயும் back bonding structure இருக்கு, இங்கேயும் back bonding structure இருக்கு. அப்போ என்ன பண்ணணும்? Back bonding தான் first consider பண்ணணும். That is correct. So here you can see two molecules in back bonding are present. Then what we should do? So which molecule is stable? Which molecule is stable? Back bonding is there. Here also you can see back bonding. Here also you can see back bonding. So I am asking which molecule is more stable. So here you can see back bonding in both molecules. So here this is more stable because of the size. Three, two, one. You guys are saying 3, 2, 1. 3, 2, 1. Everyone is saying 3, 2, 1. 3, 2, 1. Jaishankar, Joshua, Vasantra, yes, Vasanta. Okay, Pratibha. Okay, Pratibha. Okay, Pratibha. Yes. So, எல்லாரும் சொன்னது 3, 2, 1 தான். So, when you consider, here you can see 3 benzene ring, okay? 3 benzene ring is connected with the carbocation, okay? So, guys, this is more stable. So, number of benzene ring is more, okay? Number of benzene ring is more, so it is more stable. Here you can see 2 benzene ring, then it is more stable. Then here you can see only 1 benzene ring is there. So number of benzene ring increases, stability will also increases. So the correct answer is 1, 2, 3. You guys are wrong. Tanya is saying 1, 2, 3. Shweta, Divya. Why guys, you have changed your name. So next we are moving to stability of carbanion. Okay, stability of carbanion. So here you can see back bonding. Okay, here you can see back bonding. See, so when you consider carbanion, means carbanion contain lone pair of electron. If the neighboring atom should have, if neighboring atom have vacant d orbital, then what will happen? This electron will go to that vacant orbital. So there you can see double bond will form, obviously. So this is the back bonding structure. Okay, this is actually back bonding. Jaishankar is also Divya. You can see lots of Divya, but the name is not actually Divya. Here you can see different Shweta. Here you can see Jaishankar. So who is Jaishankar? Your parent? Then it's okay. So okay. So here you can see back bonding. Stability, when you consider the stability of carbanion, so first you should back bonding, then you should check aromaticity, then you should check isomeric effect or resonance effect, and after that hyperconjugation, then inductive effect. Okay, so stability of carbanion is directly proportional to minus m, minus I, minus h, and inversely proportional to plus m, plus I, plus h. Okay, I hope it's clear, my father. Okay. Then here we already discussed hybridization. So when you consider hybridization, so electronegativity is directly proportional to stability of carbanion. Okay, electronegativity increases, stability of carbanion also increases. So we know that electronegativity is directly proportional to S character. Okay, electronegativity is directly proportional to S character. Okay, then I will give you next question. Come on, guys. Come on, guys. 1, 2. So I will write your answer first. 1, 2. 1, 2 is Sukhi Abhimanyu is saying 1, 2. But Joshua saying 2 is more stable. Tanya saying 1, 2. Hello, 2, 1. Okay, I don't know. I want to check. So yes. Same thing we just now only discussed that up. So this is here you can see back bonding is there. Okay. So yes, obviously fluorine contain lone pair and carbon contain free what? No, no, there is no lone pair. No, 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 no back bonding. Then what? After back bonding, it is more stable. Okay, it is more stable. Yeah. So next, so here when you consider this, you can see conjugation. Here you can see cross conjugation. You can see extended conjugation. We know that extended conjugation is more stable than cross conjugation, then normal conjugation. Yeah, I hope it's clear. And my dear students, we already started a free crash course for NEET students. Yeah, here you can see. So if you want to join to that free crash course la join பண்ணனும்னா இப்போவே join பண்ணிக்கோங்க because என்ன so உங்களுக்கு so here you can see buy now option, click buy now option. So yeah, so yes, NEET 2026 crash course இங்க click பண்ணனும். So yes, எடா உங்களுக்கு இங்க கண்டென்ட் லைப்ரரி எல்லாரும் நம்ம கண்டென்ட் லைப்ரரி ஆக்சஸ் பண்ண முடியலன்னு சொல்லிட்டேன். ஸோ ஹியர் ஜஸ்ட் ஸ்க்ரால் டவுன் பண்ணும்போது யூ கேன் சி ஹியர் கண்டென்ட் லைப்ரரி. ஸோ கண்டென்ட் லைப்ரரியில யூ கேன் ஆக்சஸ் மோர் தேன் ஓகே pedagogy. Here you can see pedagogy, study from top books. So here you can see pedagogy. Yeah. It will take few minutes, not few minutes, few seconds. So here you can see for NEET, you can see MTG or VYQs and yes, biology books, and this is also MTG or biology book, physics book, biology book. So உங்களுக்கு இங்க இருந்து more than 100 books, reference books access பண்ண முடியும். So yes, here you can see fingerprint இருக்கு. So yes, you will get flashcards. So flashcards எல்லாமே இருக்கு. Okay. So yeah. And guys, so yes, pedagogy, this is a content library. So எல்லாரும் content library access பண்ண முடியலன்னு சொல்லி இருக்கு. Let me ask. எடா யாருக்கு content library access பண்ண முடியல? Okay. So here you can, if you want to, yes, test customize பண்ணனும்னா உங்களுக்கு டெஸ்ட் கஸ்டமைஸ் பண்ணலாம். மேபி உங்களுக்கு ஜிஓசி மட்டும் தான் வேணும், இல்லனா எனக்கு கெமிக்கல் கைனடிக்ஸோட क्वेश्चन மட்டும் தான் போதும்னா உங்களுக்கு உங்களோட அந்த பர்టిక్యులர் சாப்டர்ல இருந்து மட்டும் क्वेश्चंस கிடைக்கும். ஓகே. So next is actually yes, here we are giving 45 plus complete mock test. So இந்த டைம்ல mock test பண்றது actually ரொம்ப இம்பார்ட்டன்ட் தான். So இங்க டவுன்லோட் பண்ண ஓகே, இது register panna, you can do 45 complete. You will get 45 complete mock test. And yes. Okay, so yes, here you can see ஏதாச்சும் இதை மிஸ் பண்ணிட்டேன்னா மிஸ் பண்ணது இங்க வரும், அண்ட் லைவ் அண்ட் அப்கமிங் டெஸ்ட் எல்லாமே இங்க வரும். Okay, so yeah, and here you can see Insta solve is also there. So if you have any doubt, so inga direct கேட்டா போதும். Insta solve is actually based on NCERT. So like other than NCERT ல இருக்கிற ஒரு ஆன்சர் உங்களுக்கு கிடைக்கும், லைக் வராது. லைக் பக்கா NCERT ல என்ன ஆன்சர் கொடுத்திருக்கோ அந்த கரெக்ட் ஆன்சர் உங்களுக்கு இங்க இருந்து கிடைக்கும். ஓகே, ஸோ இட்ஸ் ஆக்சுவலி வேர் டவுட். ஓகே, ஸோ AI தான். ஸோ இட் இஸ் NCERT based AI. ஓகே, இட் இஸ் ஆக்சுவலி NCERT based AI தான். Then yeah guys, so more than 2000 students are using this. So நீங்களும் குயிக்கா இது யூஸ் பண்ணிக்கோங்க, பிகாஸ் எல்லாமே ஃப்ரீயா கிடைக்குது. ஓகே, ஸோ எல்லாமே டெஸ்ட் அண்ட் லைப்ரரி உங்களுக்கு ஆக்சஸ் பண்ண முடியும், அண்ட் இன்ஸ்டா சால்வ். ஸோ எஸ், நெக்ஸ்ட் அண்ட் ஒன் மோர் திங் யூ கேன் see here, லைக் ஆக்சுவலி கொஸ்டின் பண்றது ஆக்சுவலி ரொம்ப இம்பார்ட்டன்ட் தான். பிகாஸ் நீங்க ஒரு எக்ஸாம் சென்டர்ல இல்லைன்னா எக்ஸாம் அட்மாஸ்பியர்ல இருக்கும்போது ஆட்டோமேட்டிக்கலி நீங்க பேனிக் ஆகும். ஸோ அண்ட் அந்த அட்மாஸ்பியர்ல வரும்போது என்ன சில்லி மிஸ்டேக் வர்றதுக்கு ஜாஸ்தியா சான்சஸ் இருக்கு, எஸ்பெஷலி நீங்க OMR மிஸ்டேக்ஸ் எல்லாமே. ஸோ அதுக்காக we are introducing all India test series. ஓகே, ஸோ வேதாந்தமும் அமேசானும் ஜாயின் பண்ணிட்டு, ஸோ உங்களுக்கு நம்பிக்கை re-NEET test series இருக்கு. So from here you will get 2520 questions. Especially it's prepared for re-NEET exam காக ஸ்பெஷலா ப்ரிப்பேர் பண்ணது. And here you will get 14 full mock test and 20 OMR sheetum கிடைக்கும். ஓகே, ஸோ அந்த OMR sheet யூஸ் பண்ணிட்டு உங்களுக்கு ப்ராப்பரா ஒரு 3 hours, ஓகே 3 hoursல ப்ராப்பரா எக்ஸாம் எழுதி ஃபினிஷ் பண்ணுங்க. ஓகே, ஸோ 14 லைக் என்ன மாக் டெஸ்ட், கம்ப்ளீட் மாக் டெஸ்ட் எல்லாம் எழுதும்போது யூ வில் கெட் தட் கான்ஃபிடன்ஸ். ஓகே, ஸோ எஸ், அண்ட் இதோட ப்ரைஸஸ் ஆக்சுவலி 549 rupees தான். ஓகே, யா, ஸோ ஐ ஹோப் இது எல்லாமே கிளியரா இருக்கும்னு நினைக்கிறேன். ஸோ எஸ், ஸோ உங்களுக்கு ஏதாச்சும் டவுட் இருக்கா? Only 3% battery. Yes, I can understand. So I hope it's clear. So thank you so much guys, and bye bye.